Hey folks, welcome to Angeldust Live. I'm Frank Firefly Lucas, your host of the stream, and today we are playing Angeldust again, the action RPG for Windows, Mac, iPad, iPhone, Android tablets and phones, and Linux. So if you're watching this on YouTube, please give a thumbs up to the video, subscribe to the channel to never miss the live show, and if you're watching on Twitch, hit that follow button, thanks, much appreciated. Also, if you're watching on Steam, it's entirely cool, I'll be monitoring the stream chat as well on Steam. And write a positive review if you want, that would be much appreciated. We need just one more positive review to get back into the mildly positive ratings, which would be a good thing, so thanks in advance for writing your review. And you might even send me the link so I can read it. It's all cool, so let's go. Hey everyone on the YouTube, hey Amelia, welcome back, it's been a while. And we love shortcuts, okay? Enlighten us. Yeah, you got trolled again. It's of course my secret shortcut. My hair is a little bit shorter. There you go. You probably didn't even notice. It's a bit shorter. It's pretty cool. It's a shortcut. Hey, check it out. So everyone got trolled, which is nice and all. So once you're in the game, use the buttons on the left side of the screen to select the hero you want to play as. We'll be going with, let's see, what's the most trolly one that we can select? The Sorceress. There we go. Enter your player name and password in these boxes, and on the right side of the screen you'll find the game's social media: Facebook, Instagram, YouTube, Twitter, Twitch and Discord. The Discord server comes highly recommended. There's a lot of very friendly and familiar faces there, so if you want to get up to speed with the game, if you want to learn tricks, tips and all of the secret shortcuts, click that button, you won't regret it. It's the best decision that you probably make today, so that's highly recommended again. The website button takes you to the game's website where you can set hero colors, you can send private messages to your friends, you can name your land claims, and you can trade in all of your quest points. Because every daily quest that you do becomes a quest point, you can trade those in for exclusive creatures, which is really cool. And like big app today to Rob12. Rob12 finally made it to 420 quest points again and was able to unlock the mammoth. It's called, what is it called? It's got a cool name, so you can get that mammoth now. So. Hey everyone, hey Amelia. The wait is over, yes, the wait is over. So let's go into the game. Anyway, this button sets the in-game language, we're going with English today, so let's go. And the cartoon visual style, as always. I will join the game in the next episode. My name is Walbagune. Hey, that's very nice. Go! Wellison says, go! We're going. Hannibal, it's called Hannibal, true. Happy day everyone. Myrtle Lee, thank you. Angelio says, it's the Hannibal, it's true. Angelio, your airship got featured on the social media today. You can already take a look, but we can also take a look later on. It got featured, like winner 1 of 2, it says. And next week we might take a look at the house by Infamous. So GG on the build battle last week. Really great job. I really like the airship. I was actually, after the stream, I was like lying in bed and I was trying to fall asleep. And I was like, are these ratings okay? Are the ratings cool? Are the ratings good? And I think I still stand by the ratings that I did last week. I still think that like both the house by Infamous and your airship, they have different strengths and they have different like priorities in what they wanted to show. But I think both of them deserve to be a winner. Hey Yasine, it's not your best day today. Yeah, I just muted them. Razakti says, please give me logo cup. The logo cup will be in 45 minutes. Can you stay that long? The logo cup, it's the lottery winner badge, of course. Wow. Ali Games says, hey Ali Games, welcome. Winning lottery time, 45 minutes. More people need to discover your live streams even if they are not able to play your game. True. I'm joining. Hey, thank you Punye. Well, I created a desert village with Angelio. I need to lower the temperature in here a bit. There's too many lamps on my head and it's too warm. So everyone ready? Let us go to the hunting area. Streaming City Z. Yes. Me like sup YouTube. Yes. Nice. So lottery in 45 minutes. You can win your pet snack then. Rezaxi, so I see you. Can you stay for 45 minutes? Then we do the lottery. So, hi, been 2 weeks. Never seen your live, Mr. Firefly. Hey, Jay Carranza. Yeah, that's the Jay Carranza. Welcome. You see me live right here, right now. So feel free to join us in the game as well. We're going to play together like this. We are somewhere Forest level 1. Here we are. Somewhere. I'm picking up the game controller. USB connected. Works on the bikes, on the mobile phones, and it works on every car that you can imagine. Good morning, Obi. How are you doing? Oh, the desert village where I built one claim for fun? Apparently. Please share with everyone. Lottery of Dragon. I'm sorry to disappoint you, but there is no lottery of a dragon. But it's all good. It's all cool. You can still win a pet snack. That's pretty cool, right? It's Roger. Sorry, I'm changing my account. Don't worry about it, Roger. We got you covered. Doing well. Doing good. Do you already have, like, results of your finals, Obi? Did you ace them? Do you need to retake one quest or something? Retake a quest. Yeah, whatever. Hey, Obi, you already noticed that my hair is shorter, right? So that's the secret shortcut today. Got the results of most of my important final back on Monday. Okay. Is it all good? Amelia says... Okay, okay, Amelia. I'm glad to see you here. How are you doing? I thought I saw... Yeah, I thought I saw something like tar flying around, but... Let's tell them one more time. Rezaxi. The cup is in 40 minutes. So, about the secret feature, when will it be released? That's a good question. It's a good question, actually. I was talking about this in private messages with Rob12. Rob12 is not online at the moment, I think. I'm not ready how to. I don't really know how to. Thanks for the 3D. You're welcome, Ning Juan. I'm not really sure how to proceed. Not really with the feature, but I need to kind of like get a few thoughts in line and in order and about what's happening. So busy, yeah, so busy. That's I can feel that emotion. I expected to do the worst out of people I know, but turns out I did the best and I got a 3 out of 5. Wow, that's almost the same as the build battle last week. So you aced both the build battle and your finals. I did good enough to probably get accepted. Okay, that's nice. Congratulations, Obi. Well done. Are you going to retake one of the exams to get an even higher grade? Because in our country you can retake an exam and the highest grade will count. My back pain is in control. I feel younger. You are younger, Crunchy. You're probably the youngest on here of all of us. Oh, also Space is Green if you're still listening. I wanted to shave today, but I didn't. So that's why I'm rocking a small beard. Not sure. The only thing interesting at the desert village is what I did. Oh, there you go. It would be more interesting if people gave as much effort as I did at the village. Oh. We're not all master builders. You are best creator at this game. Thank you. I'm the best creator. I'm also the only creator. My logo cup, please. Yeah, logo cups. Logo cups are handed out in 40 minutes. So stick around and find out. I can't join, I'm in the pass. It's no problem. I did 5-5 on all the other ones. Only the Moss, which is on a higher level, was 3-5, which gives me about 83 points towards getting accepted. Sounds legit. I'd accept you. Which sounds a little bit more iffy than it sounded in my head. Let me go in the game. Yeah, sounds like a good idea, Golden Boy. I think you did great, Obi. You probably won't have any trouble getting... How to ride on a mammoth. You need to unlock the mammoth with the quest points. It's only the special Hannibal mammoth that you can ride, so it's not every mammoth. My Infinity is pushing 340 horsepower. Do you want to race one day? Sure, I'll race you one day. 300 horsepower, that's a lot. Like right now, as you can see, we've got 1, 2, 3, 4, 5, 6. We've got about 8 horsepower over here, so you have got about 40 times as much horsepower. Even more, 40, 44, sort of, give or take. I'm not saying that they're bad at building, they didn't even build at all, or at least barely a couple of nonsense blocks. There you go. Sounds like a build bot. Lol. Hey, Ghost88 is back. He's the Crazy 88. You really think there's 88 of them? Well, they ain't called Crazy 88 for nothing. What is the desert village? Yeah, we have no idea. The topic suddenly shifted towards the desert village. Desert village. Hey, Infamous, welcome back. Did you get rid of the crate, Infamous? So, true story about the build battle last week. Last thing Infamous asks at the end of the stream is, hey Firefly, can I remove the crate at my build? Now, I was like, yeah, sure, you can remove the crate. You know that the crate is like a single block in the game, right? This is the crate. Here, select crate. There you go. So Infamous asks, can I remove the crate at my house? I'm like, yeah, sure. Why wouldn't you remove the crate if you want it gone? It's like one block. Don't worry about it. What Infamous actually meant was, can I remove Pipo's house in front of my house? And then Infamous just got on a killing spree and removed the entire house. I was like, okay, that kind of wasn't what I thought you were going to do, but okay, it's gone now. A new personage, you are the new personage. You said wooden box? Oh, I thought you said crate. I'm pretty sure you said crate. Can someone rewind last week's stream? It said, Infamous said crate, I'm pretty sure. I was surprised you let him do it. Yeah, I was like, the crate, you can remove a crate block, like a single block, don't worry about it. I didn't say, like, yeah, go and demolish everything everyone has ever built. But anyway, that happened. So Pipo, if you're watching, I'm really sorry that your house was gone. I think Infamous built something back, I'm not exactly sure. But it wasn't really meant to be this way. Anyway, on to different topics. So what's happening? What's happening? A word trap. Yeah. They ask you one thing and then they do another, and they say, oh, no, I asked. Anyway, so on to the other topics. There are not many other topics. Angelio is at least receiving some points for playing together. So that's good. We'll enjoy Angelio while he's here. Pipo, if you're watching, you can demolish Infamous's crate and build something else there. No, don't do it yet, because I still need to take some screenshots for next week. This week we feature Angelio's airship on the social media. It looks pretty cool. I actually cropped it out of the live stream, so I didn't really go back and make another picture, but it still looks pretty good. And next week we'll probably show Infamous's house from the build battle. I mean, it was a pretty cool event. It was, I think, more than a year ago since the last build battle, and it was just really cool to see some of the new techniques and everyone just being more accustomed to the format. 90 minutes of building and then some harsh Firefly judgment. I enjoyed it a lot. It was really fun to do. It took a lot of time and I wasn't really like in the best physical shape at the moment because I was still a little bit sick, but it was still fun to do. It was about a 3-hour stream, I think. If my 16 square build is gone, I don't mind. I'll start over. No. Everything's forever. Like, my friendship with all of you is forever. The game is forever. And everything you build and achieve and have is forever. I built Pipo a whole new house. There you go. You're mightily kind, Infamous. You might be infamous, but you're also pretty famous. Fire friend. Yes, I'm your fire friend forever. I'm your friend till the end. Sorry, I'm not on the pause live, Mr. Fly, I'm done. Oh, don't worry about it. If you die IRL, your builds get deleted? No, that's not true. That's not actually true. Also, we had Leanda come in. Was it this week or last week? Asking like, why do I have 559 quests? And I was like, because you've got 559 quests, maybe? And they were like, no, but I didn't get a quest one day and now I'm one behind. Like, okay. And then Hum came in with the data and he's got all kinds of like statistics on Maricopa County and the whole Arizona recount ballot take thing. So there were about 20 or 30,000 ballots that were invalidly counted. And he was like, Leanda, look through this and you will see that you missed the quest. One day.
Well, that was fun.
So anyway, that was solved. And like there's at this point in time there's almost no reason to doubt any of the server code or any of the client code for that if you want. It's I think Streaming City Z is actually here. I think the game is pretty much rock solid at the moment. Except for the time you did an unclaim. This reminds me of that one joke. Like, you can build bridges and you can build castles all your life. And do they call you the bridge builder or do they call you the castle builder? No, they don't. But then you do, and I'm not going to name what you do one time, and then you're known as the forever. So there you go. Builds don't get deleted if you die. They'll be unfinished forever. Yeah, art is never finished. It's only abandoned, as Spaces Green would put it. And Gilio being dark.exe. It's true. There's actually a dark theme in the game in the next version.
I'm here if you need me.
Doubt the client, not the code. Yeah, you're the client. Slash SL359. Whoa, is that a new kind of Mercedes car? The SL359 with a 3.6 liters horsepower engine. You should talk to Crunchy about that. Hey everyone, welcome. Everyone, you probably already noticed, but like the secret shortcut is on my head. I went to the barber shop and the lovely lady said like, alright, let's get... Yeah, there's no way I can phrase this correctly, so anyway, my hair got cut. Oh, a dark feature, yeah, sort of. There will be dark theme in the next update. It has got something to do with the secret update. Glitch. Sexy hair, thank you. Like, when you go to the barber, they all have like this entire tool chest full of creams, waxes, gels, all kinds of stuff that you can put in your hair. And there's still a little bit of that stuff in my hair, and it makes it like really curly, and it's not girly but curly. And I want to take some time to get it out of my hair, and then it will be a little bit more back to normal. Where's the volume we were promised? Yeah, that's for another time. I'm having trouble getting it under control at the moment. It was... When I woke up this morning, it was like standing straight up on my head. It was like this high. If there was a picture in the newspaper, it would be a 3-day special, because like you would have to fold out the entire newspaper a few times. Please code Evil Gamer. The code will be coming in half an hour.
The light of good.
So you will have to stick around for half an hour. Then we'll do the logo cups and the pet snacks and the codes. We're curious now, yeah. The block of Cyanergia. Oh, that's a secret. Oh, the Cyanergia, that's a secret. You can get it, but it's a secret. I thought the secret feature was done and ready to be released. Yeah, sort of, kind of. Lots of parts are already done. There's just a little bit of wrapping up to do. But this is always the case with game development. You will see this on AAA titles even.
Yeah.
Getting like to 80% there, that's like half of the time, and the other 20% or 10% that's left, that's the other half of the development time. It always takes more time than you expect, especially when you have to put in all of the details and wrap it up as a final feature. But it will be coming, it will be coming. Easy bro, hee. Firefly, good to see you. I think that's GTSY, good to see you. What database server do you use for this game? Ooh, are you going to hack me? If you promise not to hack me, Ram Raider, I will tell you. I think. Do you promise not to hack me? Do you vow to tell the truth, nothing but the truth, and the whole truth? Are you gonna hack me?
The way ahead is fraught.
I will. This is like this works on the honor system. I'm going to believe you anyway. You look good with any haircut. Ah. Thanks for making my day. Everyone, thank you. That's a very nice thing to say. Secrets are never finished, only unfinished. Huh? Bro, easy for it, just wait, haha. Yeah, the code will be coming soon. Make the quest harder. I will... Oh no, I'm not going to say this. Make the quest harder. I think it's already hard enough. If we have these like major quest doers like Leyenda even missing out on a quest point, I think the quest is hard enough. I think for new players it's very intimidating to get this daily quest, and they have no idea where to find the creatures even. And then you like come to the weekend and it's like you have to hunt an owl or something, or maybe one of the more rare wheatlers, and you're like, what? Where do I find these? What's with these secret things? Yeah, it's a secret. It's also a secret. Wait for the code, bro. The code will be coming in 30 minutes. Don't care, I have the mammoth and I stopped questing. I'm 100% focusing on one of my builds now, and she says, You're not gonna hack me? Okay. Like the game and it's fast, so you want to know what made you pick the database server? Was it because it was fast? I'll tell you a secret. it's going to disappoint you, but it's going to be the best advice you've ever had. Like, you're apparently very interested in the game development or the software development side of the whole affair. Software isn't like there's not a product that is fast, and there's not a programming language that is fast, and there's not a like single thing that makes software fast. The thing that makes things fast, in my experience, is the algorithm behind it. So it's not so much the programming itself, it's not so much the software or the stack that you use, or the database server that you use, or the connection, or the server hardware. In my experience, the algorithms, so what like the mathematics behind your software, that's what counts. Of course, you eventually have to have a processor that's fast enough to process your algorithm. And in the case of a 3D game like this, you need to have a graphics chip or a graphics processing unit, a GPU, that is fast enough to push the pixels and to do all of the shading. But like the real software development and the real efficiency gains are in the algorithms. So what the server does and what Angeldust does, it runs on a like very simple stock SQL server. So it's just tables of data. And all of the data is normalized, so it's foreign keys everywhere. Like there's no redundancy in the database anywhere. So it's just a plain SQL server that's running and that's serving the data. But the genius is in how you use it, how you sometimes cache it, but also like how the server itself is programmed. It's multi-threaded, it can run on any amount of CPUs, it can run using any number of network interfaces. Unfortunately, we haven't had the joy of being able to actually scale to like 30 or 60 CPU cores and like 8 gigabit networking cards or anything. But it's prepared for that. It would run like as well as it does today, even with like thousands or hundreds of thousands of players playing simultaneously on the same server. But it's all algorithms. So the trick with the SQL server, with the database itself and the game being fast, it's just like don't query for data that you don't need. Make sure your data is normalized. Like I said, don't duplicate data. And make sure that like the actual way that you're querying your data is supported by indexes. I'm going to use indexes here because it sounds a little bit more natural than indices. I'm not sure how to pronounce it, so indexes. So that's all you want to do. Make sure you have like an efficient tree index on your data the way you query it, and it will be logarithmic, at least logarithmic in complexity, time complexity. So that means that if you double your data, it only gets like 1n slower. So this makes it very easy to have a giant collection of data, because we've got like user accounts with 350,000. I see you later, Angelio. 350,000 players. And the world has been populated by 350,000 players, so there's a lot of world data to sort through. But as long as you make sure that there's a logarithmic index on there, you can pretty much scale to infinity. Does this kind of start to answer your question? Mammoth for a quest creature in the middle of the week. Okay, that sounds like a good idea, everyone. Today's going into one of my best Presto moments. Everyone here rules. Hey, it's the same people every time, Crunchy. But I'm glad you like it. Don't worry about it, everyone, I got your comment. But there is software that is slow. That's true. Like, if you start looking at the micro optimization level, this game is written in C++, so it compiles down to native machine code. It's actually, on the server side, optimized for the actual microarchitecture of the server. I think it's an Intel Nehalem. I'm not sure how to pronounce it, but I think it's actually targeting the specific microarchitecture. Doesn't really matter because we're not stressing the server that much anyway. So C++ is pretty bare bones, pretty low level as a programming language. You can write assembler code in it as well. Kind of like assembly integrated into the C++ code, and it would compile and run anywhere. But like the algorithms are what's most important. All of the performance gains in Angeldust are due to optimizing algorithms or making sure you do less work. Like the less you do, the better. Oh, I see what you mean, Ruan, but if a quest creature ended up being a mammoth, for example, I don't think it would be a good idea to have to hunt for 10 mammoths. Yeah, okay, that's a good point. If you have to actually go for a mammoth, don't go for 10. It's not fun. Although I think that the grey mammoth is doable. I really hate the black mammoth because it's got too much health. I think it's like very hard to kill. Same deal with the violet mammoth. It's like such a health tank. It's just not fun. But hey, it's there for historical reasons. But grey mammoths, grey woolly rhinoceroses, they are pretty doable. Привет, Gaston. It's a good idea, 10 minutes to kill one of them. Sure. Seen this game before, but sad for me, I'm old now. When I see this game, I always forget names, so that I'm so lost. Hey, don't worry about it, Roger. I'm here, I'm Firefly. That's probably the only name that you have to remember. Привет. How does one even measure complexity and determine if it's logarithmic or something else? Do you really want to know, Obi? I never understood how people measure. It's just plain mathematics. Do they run it just with more data? No, Obi, it's pure mathematical. You can prove the time complexity and the algorithmic complexity of any algorithm. I think it's doable just by hand using mathematics. It's very easy to do. You'll get the hang of it in no time. Are you going to do computer science or something like related to computer science? It's probably like an intro course on that. Of course, the basics are easy and you can build on that and make it more complex. But no, seriously, there's golden horses. Golden horse. Gold horse here. Yeah, gold horse here. The startup is very fast. Okay, so that's another thing. What Angeldust does when you start it up, it doesn't do anything. That's the cool part. Angeldust literally does nothing when you start it up. That's why it boots up so quickly. And once it's actually... Yeah, you can ride one if you want, or you can kill it if you want. I'll decide. Players can see what they want to do. So it does nothing, you start it up, and then it does nothing, and then when it's actually started, it says like, hey, I'm started. It spawns a few threads, so it doesn't block the main thread. That's in like software development, it's seemingly a hard problem for other people. But I think most game engines are now multi-threaded and do a lot of stuff in the background. So then Angeldust starts up and says like, okay, I'm going to spawn a few background tasks. One for loading the textures, one for loading the world, one for loading the network communications and stuff like that. And the 3D models that you see in the game for the trees, and some of the 3D models that you see for the characters if you're playing in the 3D visual style. So once the game is actually started up, it starts loading things in the background, which is why you see the world gradually fade in and all of the textures gradually stream in. But it doesn't never block the main thread. The main thread is kind of the thing that your operating system waits on to display the next frame on your screen. So while you don't stall the main thread, the game appears to be running very smoothly. And it just loads up instantly, and then it spawns these background threads, does all of the hard work in the background threads, so that the game is actually always responsive and it never really lags or blocks. So that's the idea behind that. So anyway, I didn't even answer the question which database server it is. It's a generic run-of-the-mill open source SQL server. Now there's a few of those, so you can start guessing which one it is. And it doesn't really matter, because all of them are equally fast, seen from an algorithmic standpoint. I really want to know. Okay, there you go. We can do this very easily. Maybe at the end of the stream we can do a small segment on this, Obi.
This place has been purified.
It will be like purely example things that we will be working on, but you will get the gist very quickly. What? How? What if it's like 100 lines of code? What?
My hand against these foes.
Which snack do computer geeks prefer? Microchips. Oh, I was going to say computer chips, but yeah, chips, Myrtle Lee. I like it, thank you. Really want to know? Magical creatures have a lot of life? True, thanks, indeed. Haha, now I remember your life. Haha, yeah, I'm live. Haha. What? How? What if it's like 100 lines of code? I'm doing CS? Haven't been thought that yet? Okay. Your mind will be blown. We will do a very simple comparison between... don't look it up, don't look it up. Will you be a sport, Obi? Don't look it up. We will do it live on the stream. We'll do a very simple comparison in two searching algorithms. I'm going to channel my inner CS teacher here. We'll do a very simple comparison between two search algorithms. We're going to find a certain element in a list of elements that we have. And this is very apt or applicable to Angeldust, because it constantly needs to check, like, did you discover this creature yet? Did you discover this material yet? Is this new for you? We're going to take a look at two very simple algorithms. And you will instantly be able to see the mathematics behind it, and why things like logarithmic, so not algorithmic, but logarithmic complexity is a thing. I love it. I won't look it up. Okay, so we're going to do a very simple comparison between, and you can already envision this, a linear search. Yeah, get it? A linear search, which is exactly what you think it is. What's up? Hey, Christo. A linear search and a a binary tree search. So we're going to do 2 search algorithms. They are industry standard stuff, like the binary search tree. It's what's used at like most places in Angeldust. A simple standard binary tree search on the client as well as on the server side in the database. And we're going to compare it with a linear search. It already sounds very intriguing, and it already sounds like maybe very, whatchamacallit? It might seem very obvious, but we're going to take a look into the math, and then you will see how you can determine complexity of an algorithm. Time to eat. See you later. Hey Ram Raider, see you later. Don't be a hater. Leave a like, and guess which database server it actually is. Want to see the village me and Angelio built? Not at the moment. I'm sorry. We scheduled a computer science segment after the stream today. I loved it. I won't look it up. I think my issue is that I don't even know what is measured. Okay, there you go. Your answer will be answered. Questioned. I might sleep for a while for Sunday survival. That sounds like a good idea, Roger. Hello, Vajnavi. How are you doing? So for everyone who wants the logo cups will be handed out in 15 minutes. So 15 minutes to go. Hum says time is the magic metric. It isn't. Time is actually a physical artifact of the algorithmic complexity. Like this is how I approach it. Time is irrelevant. Time is completely irrelevant. Because time would include the speed of your processor, time would include the amount of memory that you have available, for instance. Time would include the speed at which you're traveling. Time would include... you need to exclude time. It's like purely the algorithmic, the mathematical complexity of the operation that you're trying to do. That's what counts. Because an algorithm that runs on a slow processor can still be faster than a slower algorithm on a fast processor. And I mean, like if you're actually doing high frequency trading and you actually measure on specific hardware under specific circumstances with a specific data set, yeah, then you would be able to say like time is our goal. In Angeldust, because it runs on a variety of systems, it's always algorithmic complexity that you want to target. It's not about time. Benchmarking is insane because you don't have to benchmark anything, you just make sure that it's algorithmically optimized. And then you get a game that runs perfectly fine. The boss asked if I knew where Billy was at. I said, good, employees are hard to find. Hey, good employees are hard to find, it's true. But Billy was probably hiding in the bathroom, wasn't he? So this is mainly just for search and sort algorithms. It's for everything. It's basically for everything. But it's easier to visualize, or it's easy to visualize for sorting, searching, inserting stuff into a data structure. I think those are also very common situations in computer code. You always look something up, you always have to insert some new data, you have to analyze stuff. Finding stuff is also like, it's a search problem. Yeah, so there you go. I was like, finding stuff in a text file, for instance, is searching as well. Are you gonna update your profile game? Sorry, haha. No, I'm not going to update my profile game. My profile game, I have no idea what it is. Your question will be answered, Firefly. Your answer will be answered. Yes, your answer will be questioned. I want a dragon so I can hide from my friends. Dragon, but what? But what? Angelia? Obi? We're still going on. We're still moving to the east. 15 minutes to the lottery. It's looking like a feast. And I'm looking like a beast. Oh yeah. Let's go. Christo is actually smashing this horse. Do we want one of these horses for the new players? Oh, I also need to switch to live chat. We might miss a message by Niels. Live chat. There we go. Okay, so one horse. We don't usually do this, but there we go. One horse. Lots of plus coins, which is good to see. 3 Duarda is here. Nice. So, if I could ask, what is the algorithmic complexity of printing out an amount of letters? Same deal. You're absolutely right. Like, you can... Niels isn't here, but we don't want to miss his posts. If gotta go sleep. Okay, see you later, man. Toxic. Let's post for the minutes. 15 minutes to lottery. It's actually a very good example, printing out letters. Be it on the screen or be it on a piece of paper. It's something that you can... yeah, we can take a look at that as well if you want.
I
Hey,
say
see you later, Roger. Thanks for dropping by. This live stream makes me want to play, crying emoji. But the game run with a lot of lag every time I log in. I even uploaded a video about it on Instagram a while ago. Oh, I'm working to buy a MacBook as well. Will be active once I have it. I'm sorry to hear that, Amelia. Do you share your Wi-Fi? Are you using a Wi-Fi thing? Peace out. Take two. Roger, see you later. Thanks for dropping by. Have a nice weekend. Amelia, are you on Wi-Fi? Please, me, Logo Cup. Yeah, Logo Cup is coming. Logo Cup is coming in 15 minutes. Logo Cup is coming in 15 minutes. Don't worry about it. It will require a little bit of imagination with this printing out letters thing. We can do it for physical paper as well. There's different types of printers. So in the past you had a daisy wheel printer. I'm not sure if these even get made anymore. A daisy wheel printer is like the perfect example of how you would compare algorithmic complexity for printing letters. And when you talk about the algorithm, it's more about the printing technique, which can be boiled down to a bit of mathematics. So we can compare a daisy wheel printer with a laser printer, for instance, and then you will see a huge difference in algorithmic complexity, which also explains why it takes like 10 hours to print a piece of paper on a daisy wheel printer, and why it's like 5 seconds on a laser printer. It transfers to like a lot of parts in the world. Hey, Angeldust, welcome. And Hum is probably scratching his head like, what is this dude on about? It's about time, it's about time, it's only about time. Like, in the end, in the real life and in any computing scenario, of course, like any given run for any algorithm on any piece of hardware will take an X amount of time. And you can compare X amounts of time and say like, okay, this was faster than that. But that's saying it was faster in time, but it wasn't like faster, or it might not be more efficient algorithmically. Because I can understand that something like sorting is mathematically describable, but I don't quite how you would do some more complex stuff. It's mathematics all the way down. You will see. It's just mathematics. It's not even computer science. It's pure mathematics. It's just like deducing the algorithm and deducing like what you want to achieve. Yes, I'm not lagging on other apps as well as Obi and Angeldust show that playing on PC makes sure the game is much faster, especially for builds. Okay. Alright. That's true. I mean, the input method is way more comfortable. A keyboard and a mouse works better than a touchscreen or maybe a game controller. I try to explain what the lottery is to some players, but they don't get it. Okay. Literally working for a MacBook just for Angeldust. Whoa. We've got Exogita. Wanna become famous? Buy followers, primes and viewers on this URL. Well, please don't mind me not buying viewers and followers, but thanks for dropping by. You're a good bot. Yeah, but then depends on the hardware in the printer. No, yeah, well, no. You'll see. It will all make sense. Time certainly is raising its head. I'll tell you what, time is not even part of algorithmic complexity. Time doesn't even play a role, as far as like my education goes. It plays a factor in the practical real life world, but it doesn't play a factor in the mathematics and the theory behind algorithmic complexity. Maybe I completely misunderstood. I mean, what do I know? I made a video game, that's all that I know. And I'm not like a scientist, although I am pretty scientific. Hi, I'm Man Toxic. Hey, Man Toxic, welcome. You just quit the game, so you're going to bed, right? So have a sleepy night time. Hey, well, you've got me interested. End the stream now so I can see what you're talking about. Which is also algorithmic complexity. If you just stop streaming now, we get to the fun part sooner. Hey,
The thrill of the hunt was worth the price.
It actually takes me 1 to 2 minutes to get a block placed. Is there servers in this game or something? No, it's just me. I use pen and paper. Right now someone else is doing this at the moment. I use pen and paper and then I write down all of the things that players want to do. I have to like manually put it through this machine. Then it outputs where the block has been placed. And then I have to put another piece of paper back into the machine. So that's why you sometimes get these 1 or 2 minute lags when a lot of players start placing blocks. I have no idea what this is, Amelia. Can you compare, like, can you go to your neighbors or can you go to some family members and try the game there? Is it... I'm not exactly sure if it's your device that is the problem, or your connection, or the Wi-Fi being overloaded. Like, I'm pretty sure that the game is optimized pretty well, and it has very low data transfer rates, so it transmits only very little data. which is where you can have complexity as well, but that will be for another time. Hey, golden boy. Hey, golden boy. Areas. Yeah, we've got lots of areas. Actually, it takes me... Okay. Hire more monkeys. Yeah, man. Here's another monkey. Yeah, dude. Here's a monkey. It's all punch cards powered by Firefly juice. This is how it works. I'll punch your card. Monkey's lol. So anyway, what's up, Firefly? Nothing much, man. Dude. Like I said, there's a few things that I would want to talk about with with everyone here on the YouTube chat. It's just that I need a bit more time to get my thoughts like straightened out and be sure that I have somewhat of a coherent story, because at the moment I'm not exactly sure what I want to tell and how I want to tell it. This makes it sound very ominous and very bad or very dark. It's not ominous and it's not very dark, but there are a few things that I want to talk about, which are kind of relevant to the game and to how I'm doing. But it's I don't know how to do it. Does that make sense? Don't know how to do it.
I shall go over my spells while
Firefly is sick, confirmed? No, not really, not really. That was someone else 3 years ago or 4 years ago. Players who want to win the lottery better be here. Yeah, we'll be doing the lottery in 5 minutes. Lottery in 5 minutes. I didn't try that, but I know my connection speed is pretty fast at night when everybody's sleeping, because I play much more heavy games with almost no lag, while Angeldust has lag. 2 or 3 weeks ago I rediscovered another game when they announced they released at least after 2023. What? Hey, that was that game that... Who was it? There was this person in the chat. I think it was Tinspin. I think he applied for a job for that company. It was Tencent. I think Tencent now owns that IP. Tencent in China. So that game is not going to be released until 2023. Well, I might upload a private video on YouTube and send a link. Yeah, but I already know what it's going to look like, Amelia. It will be you playing with a big red network warning icon on the screen. I know what it looks like. I've been there before. I've had this myself as well, so I know what a bad connection looks like in the game. I'm just trying to find ways to diagnose what the problem is, because, like I said, the game itself requires very little data. It doesn't send a lot of data, and it shouldn't lag for minutes at a time. Shouldn't. Do you have a special slot for your private server? Can Amelia join your private server? Do you live in Atlantis, the undersea city? Because that might affect your latency a little bit. Who else uses the iPad here? I sometimes play on iPad just to check what the game works like. I have no lag. Also, ignore the fact that I've got 2 internet connections to this place, because I cannot live with just one connection. They are not yet bundled, so they're not like bundled into one single connection, but I just switch over. Go, Logo Cup! Logo Cup! Logo Cup! Logo Cup! Does whatever a Logo Cup. It kind of sounds like this Jean-Claude Van Damme movie, isn't it? It's RoboCop. Logo Cop. You will be exterminated. I am Logo Cop.
Are you even there?
This place must be pure.
What? Please add 3D mod for Android. Hey, Ali Games, there's already 3D for Android. You can already get it, bro. You don't have to spam it twice or thrice. Dude. Ali, I got you covered.
That was easy.
I don't recall making my private server public. Oops. Please add 3D mod for Android. Please add 3D mod. This is like sounding like third person for Android. Ali Games, it's already there. Come on, can someone at least tell Ali that it's already there?
spirits will guide my hand against these foes.
When I think of Amelia, I think of two things. Angeldust and trouble. So my lag is based on my location. No, it isn't.
Well,
At least I don't think it is.
fun.
But we might need to investigate a bit. But you would need to have your MacBook. So once you have a MacBook, we can investigate using some tools that are available on the computer. It's a little bit harder to do on Android.
That was easy.
It might be like packet loss. The game is kind of sensitive to packet loss because it uses a persistent connection on the TCP/IP protocol. So if you lose some packets, it sometimes might take up to a few seconds for the server to confirm that the packet is lost. With a few other players, I ran into this issue. We debugged it, and it was just like an intermediate router problem. There was an internet service provider that was dropping packets. You can't really do much about it other than email them and say like, hey, we're dropping packets. All multiplayer games have servers. It's possible. The worst part of lag is when I misclick and place a block in the wrong place. If it's 1 to 2 minutes waiting the block to appear and then 1 to 2 minutes to remove it. What you want to do in that situation, if it's like actually taking 1 or 2 minutes, just sign out and sign in again. It will probably reset your connection. It will use another TCP/IP socket, and the previous block will be placed. Your dude will be booted from the server immediately. You will be reconnected, so your character will be forced disconnected. That's like the best. Like I implemented server reconnection because of that. Because otherwise you wouldn't be able to sign in again. Previously you would get this like sign in error because you were already signed in. But it will now forcefully remove your character from the world and only use your new connection. You gotta move. Except for offline games. Obi has got a spare bed. Name your new baby Hank or Betty.
Yeah, smells
Hank.
monsters.
Firefly Lucas. When I think of Angelio, I think of selfish and pessimistic. Don't do that. Don't do this to yourself, Angelio. Come on. Be cheery. Be proud of yourself. You're the dude who won the build battle last week.
It's getting better.
Together with Infamous. Come on. Wait, what are Stilling doing? Yeah, well, I'm still doing stuff here. I wonder how him would know that. It's sus. Interesting. Logo Cup, please! Yeah, it's time for the Logo Cup. We're doing the Logo Cup right now. Logo Cup right now. Lottery time. Ali Games, I will show you where to get the 3D version of the game as well. It's supposed to be lottery time. How to active 3D mode. Logo Cup right now. Logo Cup right now. Logo Cup.
They never saw it.
Get on YouTube or Twitch. Get on my live stream to get Logo Cup. Or win the lottery. Now. YouTube or Twitch. Get on there. We're going to be right back. We're going to do the lottery right now. Come on, we're doing this. Alright, here we go. Ali Games, how to active 3D mode for Angeldust Android. Ali Games, I'm going to paste the URL in here. You want to go to this website. It's free. Ali Games. Open that link and click on download Angeldust 3.18 HD for Android. This one, 140 megabytes, 3D, more music, more sound effects, more voiceovers. It's the best version of Angeldust for Android. Get it there, it's still free. And Julie says, when I think of Ruan, I think of gonna start a new build. It's kind of like this meme format. It's from a very old video game. It actually got discussed on Hacker News today. And it's like when I think of Maureen, which is kind of like the love interest for the protagonist of that story. When I think of Maureen, I think of two things. Asphalt and trouble. So it works kind of in that format. You think of two things and not like just gonna start a new build. But it's true. I mean, that part is true. Okay, Logo Cup, lottery. Everyone watching, go to the website. Logo Cup and lottery. This is what you want to do. Follow me. Open playangeldust.com. It's the website. You know this. Playangeldust.com. The link is just right there. You can select your language here. So if you are from Indonesia, Bahasa Indonesia, you can click that button. Then you go to the website, sign in using your player name and password, And you will need to enter this code, 52285. Enter this in the box. Enter this in the box. Like this. 52285. Submit your ticket. Boom. I am participating in today's lottery. There you go. My first thought was it might be because I live far from Angeldust server, but since Firefly say no, then I guess it's my Wi-Fi, but I really don't think it's my Wi-Fi. I live on the right side of South Africa on a small island. Whoa, whoa, oh, chill out there, chill out there. Yeah, so that's a very long, that's a pretty long distance from the server. So that could play a part in this, but a 1 to 2 minute stall is not. That's not part of the entire thing. That's not how this works. So unless there's some kind of like physical connection going on, like you connect to the internet via a pack mule or via a boat or something, then still you should be able to play pretty well. I mean, you would have a little bit of lag, so it would lag like maybe a fraction of a second. So you place the block and it takes a fraction of a second to see it appear, but it would not stall for 1 or 2 minutes. No, that's the insane part. It will have a little bit of lag. You will always have a little bit of lag because like the speed of light is infinite, or is finite. Sorry, speed of light is finite. So you can't get there like infinitely fast. But 1 or 2 minutes lag, that's not what you want. I will finish it. Okay, it's not your Wi-Fi, it's your wife. Okay, how to make people mad? Gonna make a new project every time you build a 3x3 build concept. These tech tips are off the hook. It's nerd central here. Mr. Firefly, we've been saying that. Yeah, but I'm not going to dox people right here. Trace route that. Okay, I'm hacking the Gibson right now. Streaming City Z, you're in the box. Okay, more logo cups. Get your tickets in here. Logo cups. So, Ali Games, get your ticket in there. And who was claiming to be here? AP, get your ticket in the box. AP, give me logo cup. Gland, Chanel. I explained to you. Go to playangeldust.com. Here we go. I will add you both. AP and Gland, Chanel. Go to. I'm going to make this as simple as I can, but not simpler. Go to playangeldust.com. Then sign in. Then enter the code 52285. That's what you want to do. You can do this. I believe in you. You get about 5 minutes to do this. Even with major lag from wherever you are on the planet Earth, you will be able to get here in 5 minutes. That explains it. I really hope a MacBook will handle the game better than... It's hard. It's hard to tell. If you have like intermediate packet loss, that's why we're talking about a trace route. If there is a router in between your path and the server that is dropping packets, and this might be the case, and it might also explain why other games don't have that problem, because they might take a different route over the entire globe. If there's a router outside of your control that's dropping packets, which is a thing that happens, it means that like not all of your data goes through reliably, and not all of the data that the server sends to you immediately gets there, or at least intact. So if that's the problem, a different device, a MacBook, wouldn't help, because then you would still get that problem, because even the MacBook doesn't receive the data intact from the server. So if that's the case, it wouldn't help. How do we diagnose this? It would take a computer. So if you have a different computer in your household, we could like send me a private message and I could give you some commands that we could try out. It's a pretty involved and pretty technical procedure to get to the bottom of that. But maybe you can identify the router that's like acting up, and we can try to troubleshoot that, maybe via the network center of that provider. But please logo cop me. AP, I explained it. Like, enter the code. It's a very specific island, not gonna lie. I get it now. To get your mind in order, watch some of my vids before you spill the beans. What? There you go, that's crunchy for you. Walpagune! Walpagune! Walpagune, you're in the logo cup. Walpagune, you're in the logo cup. Check this out, you're here with your ticket. Now we just need the other dude to get it in here. Walpagune, you're in the ticket box. You got your logo cup right there. It's complex. I'm gonna give up, lol. Well, like, I wouldn't specifically get a MacBook to try and see if that solves the problem. It might, but it also might not. So it's a pretty big investment for something that you don't know if it's like really going to work. Like, what's the alternative? I could move the server again, so I could move it to a different place and hope that we have a better connection. What else can I do? It's very hard. If you're only playing on an iPad, there's not many diagnostic tools that you can run directly on the device. It's something that Apple forbids, I think. Or at least there's not a network suite of tools that you could leave like running for a while. And we could diagnose the issue. But it's really sad to hear. I'm really sad to hear that seems to be the problem. Sahir is in the box as well. I'm not sure who else we're waiting for. Razaxi? Arzaxi, you're in the box? Arzak, check this out. You actually all made it. He's been asking me about the lottery for a long time. Well, you did a great job explaining it. Golden Boy, you did a great job explaining it. Because everyone who wants to have a logo cup is in the logo cup. Here, another one. Enderezado. I'm digging it. I like this. We should make another Vaporwave remix of this track. You're in the box. Great. Alright, 2 more minutes and then we'll... the code. Hey there, we've got Steve Ryder. Steve, you know how this works. Steve, you have this this logo cup on one of your different accounts. You know how it works. You need to enter it on the Angeldust website. I wish I was a cop. Call the cops. At least I think Steve Ryder has got the cup, right? Here, there you go. Steve Ryder. The original Steve Ryder is a lottery winner. And they have a pretty cool house. Hey Chokchai, see you later. Have a nice weekend. Thanks for dropping by on the live stream. Rody is in here. Don't get all of them in there. Don't get all of them in there. Glenn Channel, you're Rezaxi. Okay, great. You're in the box, so your name is on the screen. You are in the lottery raffle thingamajig, so you will have a chance to win a pet snack or a logo cup, whatever you might want to call it. We'll be drawing a winner in a few moments. Like I gave you 5 minutes. The 5 minutes have passed, so I recognize my colors. Lol. I'm not I'm not going to spoil the system behind the colors, but yeah. You would be able to recognize the colors. Hey, see you later, Obi. Trolling is an art. Anyways. Draw the winners. Yes, sir. I'm glad, Golden Boy, you're here to dictate what needs to happen on the stream. I will draw the winners. Here we go. Let's see who the first winner is. Here we go. Pa-pa-da-ba-pa-pa. The first winner is Rody1. Okay, let's instantly forget about this one. Yeah, nice house, bro. Okay, so 5 more people in the box. Let's draw a winner. Brrr, the sound effect is like very good. Rezaxi, you won the lottery. Check it out. Logo cup, logo cup, logo cup. It's right next to your name. If you sign out of the game, sign into the game, you get your logo cup, you get your pet snack, you won the lottery. Bim bam boom, bish bash bosh. It's cool. And you've been shooting some people as well. You're doing great. Nice house with the dithering and all of the colors. So GG Rezaxi, you won the pet snack, the logo cup. There you go. Draw another winner, Streaming City Z. I'm not exactly sure if this is a meme account or if it's actually someone playing. I like the house. I like the reds combined with each other. Don't worry about it. It's pretty cool. Streaming City Z, you've got the logo cup. We're going to draw one more winner. Here we go. Boom. Enderezado, GG, 12 quests, whoa, this is an actual player, 27 areas. I was going to say, I bet they've got a pretty nice house. Well, wrongo bongo. They have been shooting people, it looks good. Enderezado, there you go, lottery winner. Draw a winner, boom, Walpagone, Walpagone. This sounds like the other dude. You've got the logo cup, lottery winner badge, sign out of the game, sign in to get your pet snack. Whoa, nice house, bro. You've got some concrete going on, I think. Do we have this concrete in like these square shapes? Looks pretty good. It looks like really nice concrete. Whoa, I like it. I like it. Next up, one more winner today. One more winner. Draw a winner. Boom. Shahir, you also won the lottery. The 6th person today to win the lottery. Shahir, nice house, I would say, but it's only a swimming pool. Nice colors on your dudes. Great job there. You can discover some more stuff, but you're also a lottery winner now. Give me logo cup. Give me logo cup. You have... Yeah, seriously, the concrete is very nice. You have the logo cup. You have the logo cup already. 1. Razaxi, Glenn Chanel, you all already have the logo cup. You won. Today's your lucky day. Steve Ryder 15 is in here. Boom, Steve, you came to the right place. Steve, you entered the code on the website. You actually got what I was saying. Know what I'm saying? So we're going to draw one more winner. Steve Ryder 15 won the lottery. Steve Ryder 1, 2, 3, 4 is in the lottery. Yeah, get out of here. I'm not going to give you 2 lottery tickets or wins today. But Steve Ryder 15 has got a lottery winner badge now. So GG on that. Congratulations. Enjoy the thing. And I'm pretty sure there will be more in here. But yeah, I'm not going to draw more winners. Steve Ryder, you got at least 1 ticket on one of your accounts. The one that you wanted the most. So there you go. Alright. What were we doing? Oh yeah, we were playing Angeldust. So let's get back into the game. Here we go. Boom, bish, bam, boom, bam, bingo, bango, bongo. Let's fire it up and go to the east. Hello. Let's go. Let's say, oh, GG, all winners. If you sign out and sign in again, you get the badge and pet snack. I hope people understand this. I wish I was playing Angeldust. You could have been playing Angeldust all along. I'm rebuilding my house, Firefly. Give me logo cup. You have the logo cup. You have the logo cup now.
Yep. Spirits guide my
I really enjoy this. I wish I had Angeldust. I wish I was Angeldust.
Yep.
Oh, there were some good theories. Now I got a better idea on what might be happening. I'm used to this. Cursed from living far from servers in the majority of games anyways. There are very few games with Singapore or Africa servers. Okay. Like I said, Amelia, it shouldn't be a problem. You might have a bit of lag. I mean, that's understandable. But it shouldn't stall for minutes at a time. Like, that's my biggest issue. It shouldn't stall for minutes at a time. There's no way the server or the client is actually sending data in a way that makes it stall for minutes at a time. So I think there's like a problem with one of the routers in between. I might be able to fix it by moving the server, but that would be a very involved operation and it wouldn't guarantee success. So it's really hard to say what the best approach for this would be.
I sense evil.
I might probably have something like 450 megabytes, so focus on building and finish it. It's true, it's true. Let me sign in as streamer CDZ, okay, right. Francis. No need to take actions with this. No, but like you seem to enjoy playing the game, Amelia. You seem to enjoy like being in the community, so that's why I... Give me that wolf! That's why I wanted to like maybe try and improve your experience. But it's hard. I mean, I can't configure all of your routers. Razaxi, sign out and in to get the cup. Well, Poguna says, Firefly, I win. Yes, you won. I really don't mind. I still can play with it. Lol. Okay. If you do get this like major lag spike, sign out, sign in, and you'll be. Me have no logo cup. Yes, you do.
Here we go.
Yes, you have it. Sign out and sign in. That's what you need to do. I'm being trolled here. It's taking too much time to explain this. He did! No, he didn't. No, he didn't. I've been following this very closely. Less tips, more murdering the creatures. Okay, Crunchy, we're getting right back onto murdering creatures. Do you want a steak? Like, which part of the creature do you want?
Fun.
Have you tried signing out and in again? Yes. Or is actually, do I have to kick you? Should I kick you so you need to force log in? We already saw on the Play Angeldust website that you have the logo cup. So if you refuse to sign out and sign in, it's your problem. There are no golden doors.
Here we go.
This is heresy. You can still play with it. I've seen how you play. What? Ooh, Oogie. Thank you. You are awesome. Hey, are you the... Are you... you the original... original Oogie Ooh? You're insane. How did we... How did the topic shift to golden doors and people being insane? Oh yeah.
They will feel
I think the only mobile game in this Earth with Africa server is Player Unknown game. A game that I don't like to play. Otherwise I'm truly used to these pings. Yeah, it's... That's what happens. That's what happens, right? It's one of the side effects of being born or living in a certain place. Some facilities might not be as good as they are in other places. But it's the same with the Netherlands, for instance. I mean, if you would want to enjoy the Statue of Liberty, for instance, which is in America, if you live in the Netherlands, it's actually pretty far away. So, yeah, that's disappointing. But you can't build a Statue of Liberty anywhere or everywhere.
victory.
So here's what we're gonna do. We're gonna hunt for a bit more time, and then we're diving into our first computer science lesson on the algorithmic complexity.
Let's do this.
And it's going to be a very abstract course. Hey, Walpa. You need to catch one yourself. I really want to move one day, to be honest. I can get the sentiment. On the other hand, there's something magical about your birthplace. I mean, it's probably a place where you spend a lot of time in your youth. You're used to it. You're used to how things are going. And it's like, it's got something magical. Even if it might have its disadvantages and downsides, and maybe it doesn't have all of the facilities and all of the things that you would like to see there. There's something magical about your, like the place where you were born and where you have lived during your youth. Please send the link again. Which link?
The way ahead is fraught with
Yeah,
danger.
this is why I made Angeldust, so people can make the Statue of Liberty for me. My birthplace can go to the graves. Oh, that doesn't sound like very positive. Opa,
Now these souls can finally
can you
rest.
explain to Rezaxi they need to sign out in again in Indo? The new electric Jeeps will be able to drive underwater. What? What? Why would you want a car that is able to drive underwater? What? What would be the best place to move to? Europe isn't too bad. Like, the entirety of Europe isn't too bad.
Spirits guide me.
In my opinion. I think the Netherlands is... That's where I live, of course. I think the Netherlands is a very good place to live. It's got a very high standard of living. We've got all kinds of social facilities and social systems to make sure that even people who don't have a big income are able to sustain their lives and are able to sustain their health. We've got pretty good public transportation. We've got trains, buses, which work pretty well. So in all, I think the Netherlands is a good place to live in. Switzerland is a very expensive country to live in, as far as I know. It takes a lot of money to even be able to move there. I think you need about 25,000 euros in cash or on your bank account to be able to apply for a transfer. You need a decent education. You need a job in Switzerland already, I think. So Switzerland is a very clean, like, good place probably to live in. But it's very hard as an outsider, as a foreigner, to start living there. The one that you said we should download, it's just the itch.io link. I can show you, but it's like really simple. You can just click on the website and download APK. I want to download it. There you go. If you're really looking to move anywhere in Scandinavia, okay.
The light of the heavens shine forth.
Scandinavia.
My aim is
Scandinavia.
Ugh, smells like monsters.
Like Switzerland seems like a pretty cool country. I mean, I think the location is pretty good, and like the flag is copyrighted or trademarked. I'm not sure which one it is, but you can't just use the Swiss flag in a product or on a product because it's actually trademarked internationally. So they look like a pretty cool group of people. It is true, I could drive to pirate ships and search for treasure. Whoa, then it's more of a submarine than a car, isn't it? Like, is it heavy enough to actually sink to the bottom of a lake? Why are we even having this discussion? How do they make it work? I mean, the drivetrain and all of the components, they would be submerged. How does it even work? And the engine, it's electrical, right? So how do you prevent short circuit or like being shorted in the water and dying? Moving is very expensive. Because the currency of a salary per month in my place is about $200. That's not much. That's not a lot. We use India money. Even if most of us are French. Okay. Simple, it doesn't work. It's waterproof. Yeah, I need proof first. You can say it's waterproof, but I need watertight proof first. Seriously. Otherwise it sounds like a meme, a car that's able to drive underwater. I don't believe it. Go pull a prank on someone else. Firefly. What's up? What is up?
I sense evil here.
$200 is super cheap for rent.
The evil presence.
Yeah, but this is your salary. So you can't really like accumulate a lot of real life wealth.
Taste the bitterness of destruction.
So I understand. Maybe I should move there then. My signal, alright. So let's hunt for 10 more minutes. Let's hunt for 10 more minutes. Then we'll do a live stream segment on computer science. It will be computer science 001. It's not 101. This is even below. This is even below starting level. Okay, no, I thought it actually meant salary, so you actually make 200 Indian dollars per month, and 200 Indian dollars isn't a lot in the rest of the world. Yeah, so that's kind of a problem. So you do actually make money, and it's got a lot of local buying power, but once you start looking internationally, your buying power is actually decreased a lot. Now, and you might say if you live in the United States, for instance, and maybe you have like $1 million saved up, you would say like, okay, let me move there. Let me move to Amelia's place. Because it would be, I would be king there. I would be able to sustain my rent for a long time without having to work. But then you run into these issues like not even being able to play Angeldust without lag. I'll equip the Jeep with arrows to shoot at sharks. Wow. That sounds like a great plan. Multiply by a lot. Okay, there you go.
Feel my fury.
Sam Coder, what just left us? Level 2 Trapper, I see. What?
Victory! Huh? Yeah, sweet haul.
Where is him even? And how can he type messages? Level 2 Trapper incoming, okay?
Can they dodge what they can't see?
Give me logo cup. You already have it! You already have it! You already have it! Lol, 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 lol. You need to sign out of the game. Then sign in again. You have the logo cup.
This place.
There we go. There we go. I did it. Whoa! I've got the power. There we go. Finally we did it. Just spam them in private chat. This is how you do it, people. This is how you make people quit the game. Give me a logo cup. No. You are not worthy. Thanks, you were also. Yeah, finally, if you actually listen, you get ahead further in life. You just bully the kid off your game platform. No, I didn't. They're back and they're happier than ever. This is how it works.
I shall go.
This is my 100%
That was
kid-proof, didactical, very responsible way to show them what they need to do.
I sense evil here.
I sense evil here. Arasaxi teleports him. They just have Stockholm syndrome. No, don't worry about it. Don't worry about it. Don't worry about it. You better prepare for your computer science 001 lecture, Obi. Get ready. Prepare your mind, for you will see that it will be great. I actually really like the printer thing. I think the printer thing will open your mind even more. So maybe we should start with the printer and then look into the sorting algorithm or the lookup algorithm. Help me, please. I already helped you. I sense you're heavy in thought, your big brain.
Taste the bitterness of destruction.
Are you threatening me? Brazilian player logs off. Builder, this place has been purified. The memes practically write themselves, Ruan. You're the best. You're the best meme person I've ever met in real life. Who makes memes specifically tailored to my game. And yes, I still like... I wanna buy an Angeldust girl. She'll always hold a special place in my heart. Also, that's why I want to, like, don't hunt for too long. As you can see, I'm a little bit... I'm not sure if I'm tired or if I'm just lazy, but, like, I'm almost falling asleep here. Why? I don't know. Because I need to prepare a lecture. I wish I could buy an Angeldust. You can. On Steam, give a positive review. It would be so much appreciated. We're almost at 60% liked again, so that's good. It would make such a big difference in future sales as well, so... Dragon07 is here! Stop dragging yourself, we're going this way. Firefly, I finally did quest today. Whoa! I'm glad you did it, Ruan. I'm glad you did it. I'll give you a personal round of applause.
The thrill of the hunt was worth the price.
I'd buy stock in your game if I could. You can, Crunchy. You can absolutely buy stock in my game. How much money do you want to send? I can use every single dollar that you send me.
Can they dodge what they can't see?
Like, depending on the amount, I would even consider a contributor badge if you want to. So let me know how many thousands of dollars you want to send my way. You can buy stock in my company. Or maybe not stock, but you can at least invest in it. Don't worry about it. I like you over 60%. There you go. Angeldust publicity be like Scout saying, I want to buy Angeldust. I will even custom do a custom blockchain so you can get angel coins, dust coins. Both of them. And Obi says this is how I got my contributor badge. I paid for stock. There you go. You're a stock puppet. We're on top of the mountain. With Razaxi, Yasin, and some other players over there. Ali. Hey, would Ali Games be Ali66? It does make sense. It's all caps. It's starting to make sense here. I would invest in Angeldust if I didn't live in Brazil. Okay. Hello. Hello. Lido Jimas. Hey Lido, we saw you earlier with a English flag. Like many live streams ago, we saw you with an English flag. What's up with that? Are you actually from Indonesia and actually playing using the Indonesian translation now? That would be cool. Obi actually owns 40% of Angeldust. I'm not exactly sure about that, but hey. You are on the Wonders list, which is very wonderful. It's downloading. Ruan is saying in a very convoluted way that he's not investing in the company. Presto stock is on the rise. Yeah, hey, big mouth. Send me your money, then we'll talk. This is how you raise money for your company. This is how you do it. Hello, I'm Ali. Hey, Ali. I'm Firefly. Josel, the crack is here. Now I know that this in Spanish, el crack means the best, so Jose is the best. Brazil is too broke. Oh. Determine the algorithmic complexity of how much Angeldust I own. Okay, we will. Have a good night. Bye bye, Amelia. See you later. Thanks for dropping by. Try the game at times, see if the connection clears up. I'm really sad that you aren't able to play more, but we might look into solutions for that in the future. So stick around. Thanks for dropping by. Have a nice weekend. And even though I don't see you as often, you're still in my heart, baby. Anyway, let's go to the east this way. Send me 800 euros, Obi. Oh, are you threatening Obi? Because then I will remove your chat message. Put up or shut up. No, you're welcome anyway, Crunchy. I like you being here. You kind of liven up the place. You're always a delight to see. You're always talking about hot rods, horsepowers, fixing mugs, ladies, Myrtle Lee, who coincidentally is a lady. So yeah, it's all good. Same for everybody here. Ciao ciao, ciao ciao. Iran is going. Firefly, how would I treat Obi? Threaten Obi, oh. I'm not sure. I'm not sure how you Brazilians do it, but you might just do it. Is this snake going to be the end boss? Nah, we're going to look for one more big creature. Hopefully a troll or something. GM Hum is joining. GM Hum is joining. What is happening then?
Yeah, sweet call.
Okay, let's search one more cool end boss for the hunt. Here we go. You got shanked. What? Why? This is suspicious. Why are the two hums floating in the sky? Is there something to be gotten here? Is there something that I'm not seeing? Is it this red owl at level 7? Is that special enough to actually teleport in some alts? I don't believe it. Full screen now. It's actually full screen. Obi is actually teleporting in. Why? Daddy, why are you here? It's not special enough. Okay, but we'll kill it. We'll try to kill it though. Don't worry about it. The sound when someone is exhausted, it's just the best. You just thud, and then they dead, then they rip. Oh, by the way, I'm a sorceress. I can heal people. Check this out. I can actually heal people. Oh, Jim was here to talk to a player. Okay. Obi actually teleported by accident. Okay, let's.
It's fun. I sense evil here.
Let's find another creature. Let's forget about the owl. The owl is irritating me, so we're going to the east this way. You know, you found a very rare creature when an army of hum teleports next to the creature. Yeah. That's why I was thinking that this was another one of those special rare creatures. Iran, we're going to help you out here. Trying to kill this wolf on your own, it's level 7. Hello, Babe.
Let the light of the heavens shine forth.
Sorry, wrong
The
chat.
thrill of the hunt
Don't worry about
was
it, everyone.
worth the price.
Let's get these Wheatlers as
Smells
end
like
bosses.
monsters.
Wheatlers as end bosses for today.
The evil presence is banished. Let's do some hunting.
Obi, I'll also remind me if I forget. At the end of the lecture, I hope it makes sense. At the end of the lecture, I will send you a link, or I will give you a link, or I will look it up on YouTube. A link to an actual lecture series, even on computer science and data complexity or algorithmic complexity. That's very useful, especially in the beginning when you're starting to learn this stuff. Or maybe it's a bit too advanced. I don't know. I had no problems following it. But there's a pretty cool lecture series on this, and it really helps put things in perspective. You will remind. Okay, there you
The
go.
thrill of the hunt was worth the price.
Yeah, so this was the hunt for me today. So this was my hunt for today.
Let the light
Thank
of
you,
the
thank you all.
heavens shine forth.
Oh, there you go. Well, you sorted out. Hey, but these imaginary rules is it's not done. It's not done. Thanks for hunting. I'll be back next week. Not sure yet. Not sure which day just yet. I'll have to look at what's possible. Have a nice weekend. See you next time. So let's say bye and thank you for playing to all of these players. Bye and thank you for playing. Right, I'm going to sign out of the game like this. Desktop view, options and quit. So the hunt is a little bit shorter today because I won't say I'm low on energy, but like I'm not at my best either. So here we go. We're going to do a bit of computer science. This is something completely different, but here we go. Let's go bowling one day. Sounds good. I'm going to open up MS Paint. Here we go, because we need a canvas to work on. Not imaginary, just not enforceable. Oh, there you go. 2 and 2 is 4. That's exactly correct. Let me get a good brush. This is visible, right? Yeah, okay. So, algorithmic complexity. Let's start out like with a very high-level definition of what it means. What we're going to be looking at today, or in this like very short lecture on this, an algorithm is a means, a method, a mathematical description of steps on how to achieve a certain result. So an algorithm is nothing more than sort of something like a recipe for baking something. An algorithm is just a step-by-step instruction on how to achieve a goal that you have in mind. And the algorithmic complexity or time complexity of that doesn't actually involve time. We're going to take a look at that maybe in a subsequent lecture. But time is not really the essence of algorithmic complexity. The essence of, or the unit of algorithmic complexity is in the steps, the number of processing steps, be they comparisons or be they like data storage, data reading that you're doing. So algorithmic complexity is like in the examples that we're going to be looking at today, is kind of defined in the number of comparisons or number of steps that you take to achieve the end goal. And in real life, these will translate into a certain time that it takes to execute the algorithm on a certain input set. But that time also depends on the speed of your processor, like the device that is actually processing the algorithm, the efficiency maybe in which you convert the algorithm into instructions for the processor, the size of the data set, the speed of the data transfer between the data set and the processor. We're going to ignore all of those things. We're just going to look at a mathematical view of an algorithm. So imagine, if you will, What are you doing, Stab Bro? Here we go. So imagine, if you will, we're going to do this. It's going to be all imaginary, very simple test scenarios, but it's going to explain a few of the simple concepts that underlie algorithmic complexity. Also, it might not be like mathematically like super perfect and accurate what I'm going to tell you, but these are like the general principles that you will learn in a computer science class on data structures and algorithms. So kind of bear with me. It's not perfect, but it's kind of like a very, very simple explanation in very simple terms of what algorithmic complexity is. So remember, an algorithm is a recipe or a step-by-step instruction on how to achieve a goal. And the goal that we're going to be looking at first is to find a specific, find if a specific element is in a given data set that we have. So for this simple example, we're going with a data set of 8 numbers, and the numbers are 1, 2, 3, 4, 5, 6, 7, and 8. This is the set of numbers that we're going to work with. It's very simple, it's all very theoretical, so this is not a practical example, this is not something that's actually part of the source code of Angeldust, but we have these 8 numbers, we have these in our system in a computer, and we're going to take a look at 2 ways of finding a number in this set. And now you can do this very much more efficiently because it's actually a continuous range of integers, and it's all good, but we're... Oh, hey, see you later everyone. First time I'm learned something. Okay. Paint as a textbook thing that you can use. Yeah, but I'm going to have to draw these in different orders and stuff. I hope you can read the numbers. So, like one way to do this is to toss all of these things in a storage. Our storage in our system is going to be totally abstract. There's not going to be any like specific computer stuff involved. We have storage, we have numbers, and we're just going to take a look at if we have our number. So for we don't yeah. So here we go. We're going to do 2 different algorithms for this: a linear search and a binary tree search. The binary tree is going to involve a bit of like mathematics and a bit of shuffling that we're going to do. You can ignore most part. We have a part magic and a part explanation today. So the linear search is very simple. Like let's kind of like make this a memory layout. So this is computer memory, and we have 8 numbers in there. You can kind of see these in boxes. So we have 8 boxes, and there are 8 numbers stored in those boxes, like this. Here we go. Here we go, like this. So this is 8 boxes, 8 numbers. There you go. Yeah, we're going to add some IBM stuff later on. Send salve to Arthur Lionel, maybe, salve. Linear search, each number in a separate shoebox, open each box and look inside. Okay, so the linear search, let's indeed use this. So linear search, each number is in a shoebox. Open each shoebox to see if it contains the number. It's a pretty good description. We're going to roll with this. Thank you, Hum. So this is what a linear search is. This is the linear search algorithm. Our goal is to find if we know the number, and the way to get there is to open up every box, or in computer terms, look at every memory location containing a number and see if the number is in there. So for instance, if we are about to, we're looking for number 5. There we go. We're going to look for 5, and this is going to be somewhat interactive. So let's go back to the brush. So how do we look for 5? So is 5 in the box? Is 5 in one of the boxes? This is going to be kind of our question. If you need to move stuff, you can use the select tool thing. Yeah, okay, but we're not going to move stuff. Well, for interest, let's do a random search. We're going to randomize the linear search a little bit because our numbers are in order. Doesn't really matter. But we want to know if 5 is in our data set, if 5 is known in the system. So we open the first box. Step 1. Open the first box. Is it here? So no, it's not here. Step 1. Like the number of red the number of red glyphs or number of red elements is actually the number of steps that we take. We go into look in the second box. It's not in there. It's not in the third box either, but we have to look. It's not in the fourth box, but we have to look. It is in the fifth box. Okay, cool. So we found it. We can actually stop looking for this. But so in 5 steps, it took 5 steps to find the 5. So we do have the 5, but it took 5 steps. We're going to look for the number 10. Is 10 part of our series? So another linear search. We have 8 elements. We didn't really specify boundaries for those numbers, so we actually have to... we know that 10 could be part of one of the boxes. So we do the blue search, the blue linear search. Is it in box 1? No, it's not in box 1. Is it in 2? No, it isn't. It's not in 3. It's not in 4. Already we did 4 steps in the algorithm. 5. No. 6. No. 7. It's not there. 8. It's not there. And then we have all the boxes. So it actually takes 8 operations, 8 steps for the number 10 to be found. Or at least we know it's not there, so it takes 10 or 8 steps. It takes 8 steps to deduce that the number 10 is not in the set. So this is our linear search. Now you can say like, okay, and now we move on to, no, we don't take the probability. Here we go, Obi, here we go. Throw everything you know out of the window. What we are looking at with algorithmic complexity is most of the time it's the big O notation. And this might sound very funny for someone who's your age, a big O notation. You actually write this down like a big O, so it's the letter O. And this means, this is kind of a mathematical operator or a mathematical definition. The big O of an algorithm means what the maximal number of steps is to get to the result. So, like in the worst case, sort of. So, it doesn't matter what number that you look for in these boxes. You know that you, in the worst case, will always have to look through all of the boxes. So, all 8 of the boxes will have to be looked at to know if a number is in the box or not. We had luck. We had a luck with the first number, with the 5. You could get even more lucky with number 1, because it would be in the very first box in this scenario. But in the worst case, you will have to look through all of the boxes to find out if the number was in a box or it was not in a box. And that's kind of like the big O notation. What's the worst case runtime? What's the worst case scenario? What's the worst case number of steps that you have to take to actually like walk through the entire algorithm, open up every shoebox. And if you say like we have 8 shoeboxes in this case, in this scenario, the runtime of the algorithm is O, and then it's a parentheses open, an O of 8. So that's our worst runtime. It will always take 8 steps or less to get to the desired result. I thought it had a Greek name. No, this is time complexity, algorithmic complexity. Hey Niels, welcome, 34.3. You're welcome, Niels. I was specifically in live chat for you. We're doing some computer science here with Obi and with some others who want to do so. Or we are talking about how to keep a shoe store running. Yeah, we're Al Bundy, we're shoe salesmen, and 4 touchdowns in one game in Poke High. You know this. So anyway, in this specific scenario, 08, like the worst case runtime is 8 steps because we have to look in 8 shoe boxes. Now you can generalize this. So this is where the N comes in, which you were already posting about, Obi. If you say like we don't specifically have 8 boxes, but we have N boxes, N being the number of shoe boxes that you have with random numbers in them, or maybe they are sorted, doesn't really matter. If you have N shoe boxes, the running time, so say that like the number of boxes, N is the number of boxes. Very nice text, Firefly. That leads to the runtime, the worst time runtime of the algorithm becoming O(n). So that's kind of the generalized form of this. So in this case we have 8 boxes. So this is like why we have the green 08 here, because we've got 8 boxes in total. If you want to generalize this with linear search, you have to perform N comparisons. You have to open up each box to see if the number is in there. So you know that you can be done earlier than that, but in the worst case time, and that's kind of like what you do in computer science and in Angeldust and in actual real life products, you can't assume the best case scenario. You can't assume the average scenario, sort of. So you kind of have to depend on the worst case complexity, the worst case scenario. And a linear search in the worst case will take n shoeboxes to be opened and looked into, and you will either know that you have the number, and it might even be earlier than n steps, or in the worst case you have to actually perform n shoebox comparisons, n times opening up a shoebox to see if the number is in there. Get it? O n, no. Now I want to see what an O is worse than n. If you looked at each box twice, sure. You can do a linear element search. So you would say like, you get these problems if you start matching from two sets, for instance. You could say like, is a number... No, let scratch that. We're going to do the binary search first. Please, how do you tame the dog? You use the cookie on it. Ali Games, and don't start spamming. Use the cookie on it. Obi, you get this, right? So linear search is linear, is O(n), so worst time complexity of n steps, because you have to open up n shoeboxes. Obi, you get this part? So save this, or you can rewind the stream later on if you want. Yeah, I get it. Okay, so we're going to look at the same problem first. So a search again, but this time we're going to use a binary tree, a balanced binary tree, because these numbers were casually taken so that they actually make sense. I got it as soon as you said worst case scenario. Okay, so here we go again. We are going to rearrange the numbers instead of like this linear array, which is actually called an array in computer science, or a vector. So instead of a linear array or vector of these numbers, we're going to arrange them in a tree. And this tree has got a specific property that you have like a root node, which is the start of the tree. It's got leaves. And the theory is that every leaf to the left of the root node is smaller than the root node, and every leaf to the right. So every like a super node has got only 2 children, and every left child has got a smaller number than its top node, and every right child has got a bigger number than the top node. So I have to do this by memory. I might make a mistake here, and maybe I'll use some different numbers. But it would be nice to use the 1 to 8, but I'm not sure if it actually works. So we would have we need to use 7 numbers, actually. So the tree is going to be a bit different. So we're going to use 4 at the top, and then we're going to do it like this. It's not going to work for all of the 8 numbers, but bear with me, this makes sense. Here's the 6, here's the 2, I think, at least. And then here we have the 1. And there are ways to store this in computer memory, but just kind of assume that we have the shoe boxes stacked in a pyramid like this. We're going to stack pyramids, the shoe boxes like this. So let's make shoe boxes out of them again. Like this. So we kind of cheated, but you can kind of make the linear example 1 to 7, and then it makes sense. So there are ways to efficiently make this representation. So again, we're going to hand wave a bit of stuff, and we're going to use a bit of magic here. But like this is the way we're going to arrange the shoe boxes now. There are 4 shoe boxes at the bottom of the stack, 2 shoe boxes on top of those 4, and there's 1 shoe box on top of those 2. How you do this in like the physical world doesn't really matter. But we're going to assume that we have the same number, so 1 to 7 instead of 1 to 8. But like in the linear search, it would be 07, so worst case of 7 shoe boxes you need to open. And now we're going to do a binary search. So binary search is very simple. No, it's very simple. So a binary search, and the algorithm is check if our node is the what we want to find. So let's call what we want to find the target. So check if our shoebox is the target. If yes, we're done, because then we know that it's actually part of the set. If no, check left. If the shoebox is bigger than the target, or check right if shoebox is smaller than the target. There we go. Yeah, we call them 3 nodes, but I want to keep this simple. So this is the binary search, and you just repeat this step. So this step, oh, you can't highlight the text. These bottom 2 steps, they repeat, or kind of all 3 of them. So we start at the root. We check if our shoebox is our target number. If yes, we're done, because then we've already found that the number is in the set. If no, we'll check the left shoebox. If we're going to check to the left if our current shoebox is bigger than the target, and we're going to check right if the shoebox is smaller than the target. So shoebox is kind of like the current node. Keep that in mind. But we're using shoeboxes. It's a very nice visualization. So would quantum help streamline all this? Crunchy, that's a question for a different time. Here we go. We're going to take a look at the scenario for the number 7. We're going with the biggest one. This was actually worst case. This is worst case in the linear search, because like in the previous example, if they were all sorted, you would have to look at all the shoeboxes to find the number on the right. So what do we do for the number 7? We check in 4. So we actually check this one. Let's mark it with an X. 4 is not 7, so we're not done. So we have to check we're not done, so it's not like this second step is finished for 7. If no, we're going to check to the left if the shoebox is bigger than the target, or to the right if the shoebox is smaller than the target. Well, the shoebox is 4, our target is 7, so the shoebox is smaller than the target. We're going to check to the right of the 4. We check this one. It's the number 6. Okay, so it's not number 6, because we're looking for 7. So we still don't know if 7 is part of the set or not. Again, we repeat the algorithm, same deal. 6 is smaller than 7, so the shoebox is smaller than the target. We're going to check right. So this is the third check here. Boom, 7. Okay, it took us 3 steps, as you can see. 3 steps, and it is actually in the box. I don't get what is a shoebox. A shoebox is this. A shoebox has got a number in it. Angelio, these black squares, they are the shoeboxes. 3 nodes, or whatever you may call them, memory locations, if you want to get really technical. So actually this should be a check mark, because we actually found this. It's a check mark. Whoop. We found it. 3 comparisons. We've got 7 elements, but we only had to compare 3 of them instead of 7. I love Angelio. Okay, now we check the number. Let's go with green. We check the number 3. It's a pretty interesting one. So is 3 in the set? First, we're going to check the first shoebox. No, this is not it. And because the shoebox, number 4, is bigger than the target, which is 3, the one we're looking for, we're going to the left this time. So we're going to check this one. Let's get a green check mark going here. Okay, so this is not 3 either. So then we say, like, is the shoebox bigger than the target or smaller? So our target is, this time, the shoebox is smaller than the... Did we run into a problem here? The shoebox is smaller than the target, so we need to check the right side. Okay, and then we end up at 3. So also 3 steps for the 3. Okay, that's really cool. I think this would be better if you did another layer of nodes. Yeah, but then it gets really complex. It gets really complex. But it generalizes. You will see. It generalizes. Now we're going to look for 10. So this is also something that we need to check. Or maybe let's check for 0, which is a pretty interesting idea. Let's check for 0 instead of 10. Because then we actually move into a different area of the thing. Color. I have no idea how this works. And now it's not a filled. Yeah, there we go. Really nice. Brush. Blue. We're going to check for 0. So again, we have to check the top node like this. Boop. You could also check for 2 or 6 or 4 maybe. But like we're going to traverse all of these. So 4 is not 0, so we're going to the left. 2 is not 0, we're going to the left. It's not 1. And since there are no child nodes, we're done in 3 steps as well. So now it looks like every solution takes 3 steps, but that's the worst case scenario actually. So if you look for 4, it only takes 1 step. If you look for 6, it takes 2 steps because you go 4, 6. If you search for 2, you check 4, you check 2, and then you're done. So again, worst case scenario in this tree is 3. In this tree is 3. There you go. So the number of checks is not in the worst case scenario, the number of checks or the number of comparisons that you do is no longer equal to the number of elements, but is actually equal to the height of the tree. And the height of the tree is like the number of levels that you have in this binary tree. And as you can see, each subsequent level, if the tree is actually fully filled, has got twice the number of leaves or of nodes. Sorry about that. So this is the number of checks that you have to do in the worst case, because you never have to move up, you never have to go like to a different direction. Every time you go down a level in the tree, you know that you're going in the right direction, because we're going to assume that this tree is actually balanced and the numbers are actually filled in correctly, because if you're working with the like an incorrect data structure, the algorithm doesn't work. So this actually leads to like in the case of all of the examples that we had here, to an O3. But in general, this is actually like the height of the tree is the base 2 logarithm of the number of nodes that you have. Because as you can see, this is like 1 node, 2 nodes, 4 nodes. And each level that you add, like the next level would have 8 nodes. The level below that would have 16 nodes. The level below that would have 32 of these shoe boxes, nodes, 64. So every time it's like times 2. It's actually like raising 2 to the power of n. And as you can see, like if you take one more step down the tree, this is kind of like the inside. Obi, you're close, but it's actually like the base 2 logarithm of the number of nodes that you have. Because every level that you add to the tree, which is one more check that you have to do, like every worst case more check that you have to do, you can search double the amount of nodes. And this is like the algorithmic insight that you have here. This is why this binary search tree is an algorithm that's almost like impossible to beat for random data, for a random number of like elements that you have and a random distribution. Because like worst case, you take one more check and you can check double the amount of nodes because you only have to do one more comparison. So as the number of nodes and numbers that you want to check doubles, you only have to do one more check because that's the property of the balanced search tree. So you end up for this example with an O of log, and you could like write down the 2 here if you want, O log 2n. So true. And this is why like this structure for like almost any database that you have, depending on the data, you can do a bit more efficient things like a quad tree for 2-dimensional data, an oct tree for 3-dimensional data, or whatever, if you have 3-dimensional coordinates, for instance. But like in general, this is, as far as I know, mathematically and algorithmically, just one of the base default good algorithms for searching an element in a set, or checking if an element is there, or doing other specific stuff like finding ranges or something. So, like this is algorithmic complexity. The linear search, as you saw, was ON because you actually have to open up n shoe boxes to find like an element amongst n of those shoe boxes. And the binary search, because of like the more optimized data structure, you only have to check the logarithmic base, like the logarithmic 2 base of n, the amount of nodes that you have. So is there anything better than log 2n? Yeah, of course there are algorithms that do better than this in specific conditions. I mean, generalized, this is like the best search algorithm, I think. But there are specific situations where you can do better. For instance, take the very contrived example of you always have the numbers 1 to n, right? You always have the numbers 1 to n in your boxes. Like, if you get one more n, you always have like all of the boxes in front of it. So for instance, you have the numbers 1 to 8. They are in your set. And there's you get number 9 as well. So you always have a continuous range of numbers from 1 to the number of boxes that you have. Then the check is trivial, because then you just check if the number that you want to search for is smaller than the number of boxes that you have, or equal to the number of boxes that you have. And that's actually an O1 algorithm. So because you know that you always have this amount of boxes, you know that all of the smaller numbers are always contained in that set, and then it's an O1 check. So that's like a trivial example of a scenario where you can optimize a search algorithm because you know some specific preconditions. Algorithmically, binary search with a balanced tree is unbeatable as far as I know. And you can actually prove that. You can actually prove, because, and that's what this series, the lecture that I was going to link you to, is going to show you. Because there are 7, you can turn this problem around. And I'm not actually sure how to do it live here on the stream. You can turn this around. Instead of looking at solving the problem algorithmically, you can take a look at the result space. Like, you need to be able, this algorithm needs to be able to give a specific answer for all 7 numbers that are included in the set. And because you want to return all of those 7 numbers, the algorithm has to at least take a certain step, so like the log2 step, the log2 number of possible outcomes, to be able to discern between all of the inputs and outputs. It's detailed in one of the lectures that I will link you to later on. So you turn the problem around and you look at like how many outcomes does this algorithm have for like specific numbers, and then you can deduce a minimal complexity for the algorithm as well. And binary search is like the ideal worst case and minimal case algorithm. Yeah, Ali Games, if you don't stop, I will time you out for a bit, please. Anyway, that was linear search, binary search. Shall we take a look at the letter printing as well? Because the letter printing is actually a very cool example as well. Well, cool example, but like it translates into the weird stuff. There is no weird stuff. So let's take another page. I don't have like a ready-made example in my head. I do know what I want to tell you, but we're going to take a look at the difference between a daisy wheel printer and a laser printer. So let's take a look at 2 pages. In Europe we use A4 sized paper. You are weird stuff, okay. We're just going to interactively kind of work through this. It's not going to be like a major topic in your computer science class, but it's to kind of show how these algorithmic steps translate into physical movements and into the physical world. This is going to be a daisy wheel printer. Look them up. You can even say dot matrix if you want, daisy wheel or dot matrix. A printer. This is a printer type that's got a print head. It's kind of like, maybe inkjet is the same. We could also call this inkjet. Inkjet, dot matrix, daisy wheel printer. And this is going to be a laser printer. And now you actually do need a little bit of background in the technologies that these printer types use to get like the image onto the paper. All right. So suppose it's going to be a contrived example, of course. Here we go, solid color fill. Suppose we kind of have like a nice drawing that we did, just like this. Boop. And let's copy over this entire drawing to that part. Okay, so I'm used to Alt, kind of like copying stuff in Photoshop, but Paint is having none of it. Alright, here we go. It's going to be hard to visualize this in Paint and without like actual props in my hand, but it's all good. We're going to kind of work our way through it. So you might have already seen a inkjet or dot matrix or a daisy wheel printer in real life. This printer's got a print head. So kind of let's assume that both printers process the paper from top to bottom. So they both go this way. So the paper is processed like from top to bottom like this. That's the processing. So there are optimizations, but mechanically, like there's this print head. You've probably already seen this. It kind of looks like this. It's a print head, and the ink comes out like at the smallest point over here. That's what actually prints lines onto the paper, and that's what actually puts the ink onto the printer. So what's going to happen here is that the computer that you're printing this from might be directly attached to the printer and might actually like mechanically steer the printer, or maybe the printer's got a built-in rasterizing unit. But anyway, somehow the image that you want to print gets converted into like the mechanical movements that the printer has to make this drawing. So what happens with the inkjet or dot matrix printer, this is kind of like the algorithm that it has. It says like, okay, scroll down the paper until you actually have ink on the paper. So this is going to be a black and white page. I was more thinking of printing letters to the screen, like algorithm that prints out n amount of letters. Okay, but this is even more interesting, sort of, Obi. This is kind of more interesting because it shows an algorithm mechanically in real life. So what this does, it would say like, okay, scroll down this amount of paper, because now we actually have to move the print head all the way here. So it moves over here to print something. Then we print this. Okay, it's all good. Then we kind of print this small piece, sort of. Then we have to move all the way back because we actually have some lines over here too. And then we go back again. Then we end up here. And then we move all the way here because we actually have to put down some ink. Then we scroll down the paper, we go all the way to the left. Here we start printing again. Then we do this top piece over here. Okay, very cool. Then we're just going to cut this in half. Then we go down, we go over here. It actually does a zigzag pattern over this. So you can actually kind of like zigzag this in. This has to be zigzagged. This has to be zigzagged. Then we go down again a little bit from here. And then we go to the left. Then we have to move all the way over. Yeah, it's kind of intermixed here. We move all the way over here, which is zigzagged like this, whoop, and like this all the way down. Like this, and then we go down here. We zigzag this entire portion because we continuously have to move left and right to have the left and right downwards strokes on here, which is why printing horizontal lines on an inkjet printer is much faster than printing vertical lines, because like two vertical lines, because the horizontal line is like whoop and it's printed, and then I can just whoop scroll down the page and say like, okay, this was done. And a vertical line, you continuously have to move to both edges of the paper. So there's a fun optimization challenge in there, like do you print more horizontal lines or more vertical lines? So it might make sense to put in the paper rotated 90 degrees. Here you have to scroll and then you do this entire piece. It's actually a pretty complex page to print. So another zigzag pattern all the way down. Here's another zigzag pattern all the way down. Here you scroll the page again, move over here. Then you move over here. You actually print this part. Then we zigzag this entire thing. Then we have to go to the right one more time and then scroll down the paper and we're done. There we go. So this is kind of like an algorithm. This printer has got a print head. It can only print very locally. So it actually has to kind of like find a good path throughout all of the like tiny specks of ink that have to be put on the printer. And it will, you know this, if you've ever printed on a dot matrix printer, you know this beep, beep, beep sound that it makes. If you're on the inkjet printer, you probably notice that it goes like and it might make a different sound while it's actually printing, and it might make a different sound like when it's actually moving the paper around. But it has to do all of these complex steps because it actually has to physically move the print head into location, print something. And like I said, vertical lines in this fashion are very hard to do because it's got like only a small strip to print vertically, but it has to move all the way left and right if there are any other vertical lines. So you get a lot of empty space, but it still has to be traversed by the print head because it can't go back. It will print from top to bottom and you can't go back. So you have to do everything in a horizontal line. Yeah, beep, boop, 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 boop. That's exactly what I wanted to say. So anyway, you can kind of like make an algorithm for this. So you have like every arrow that you see here is kind of like an operation that you have to do. Either scroll the page, move to the left, move to the right, start printing, stop printing. Like this printing a piece of paper on the inkjet dot matrix or a daisy wheel printer is, and I'm going to write it down here, is ON. Where n is actually, and you might go for n squared or whatever. It doesn't really matter how long it takes to do each individual operation. In the end, you're waiting for ON steps to be completed. It has to go to downwards. It has to go to the right. If you print an empty page, perfect. It's a like a one-step operation, but you still have to perform that one step. If there's only a single a single dot on the paper, you have to perform one operation to scroll down, one to move to the dot, one to print the dot, and one to push the paper out. So that's 4 steps. So you can't really say like there's a very efficient way of printing a non-empty page on a inkjet or dot matrix or daisy wheel printer. So that's kind of like ON complexity. Doesn't matter how long it takes, you need to do a lot of steps to get to the end. A laser printer, on the other hand, is ingenious in the sense that it has a drum. I'm not sure if you actually saw a drum in real life. A drum is kind of like a circular, maybe you've already seen this piece in real life. It's also on copiers and on other stuff. This is an imaging drum. So this is actually a roll, kind of like a magnetic roll. I'm going to call it magnetic because I don't actually know what technique it uses, but I think it's magnetism. That actually rolls. So this is a thing that rolls. And on one side you have like a computer attached, or like a driver controlled thing that puts magnetic stuff, like a magnetic charge, onto the roll. That's in specific spots. And now the cool thing is that it only puts the magnetism along the lines, like on the parts that are coming up on the paper. So it will actually magnetize or charge, electrically charge this thing. So there you go. I'm back, Firefly. Hey, welcome, AP. So it will charge this roll, and then once it reaches the other side, because the roll is actually turning at the speed that the paper is moving through the printer. So assume that these are all like electrically or magnetically charged stuff. On this side is the toner. So here's like, I'm going to draw this as a box, because it kind of like is a box. Here's a box with toner. Toner is like very fine powder. It's kind of like ink, dried ink as very fine powder that actually attaches to magnetic stuff or electrically charged stuff. So this is a box of toner. I'm going to draw some more toner over here. So what the computer does, and like let's assume it's a computer, but it can also be the printer itself. This is the computer. The computer tells the printer like, hey, I'm going to assume that the speed of the paper is going to be like 2 centimeters per second or whatever. It's a nice box, hey Crunchy. It's a nice box, isn't it? Hey, Mr. Lido, welcome. The computer is going to say, okay, I'm going to assume your toner, your drum roll, or your driver tells me you want like this amount of centimeters per second. So here's the next line, here's the next line, here's the next line. So the computer is continuously transmitting data about these shapes that are going to be on the paper. This wire or whatever it is, I have no idea how the technology actually works. This wire actually charges the imaging drum, so it actually makes sure that the drum is electrically charged or magnetically charged or whatever. Then the drum rotates along, more and more lines are added to the drum for the upcoming pieces of paper. The drum moves along the toner, so the toner, like the small particles of the ink, get attached to the charged pieces of the drum, and then it gets like transferred onto the paper by heat or something, I'm not sure, or maybe it's a laser, because it's called a laser printer, I have no idea. But somehow the ink finds its way onto the paper at the speed that the imaging drum is rotating at. So now you might ask, like, what is eventually the complexity? And the complexity of this system is like, and this is going to blow your mind, it's 01. Why is it 01? It's one single step. Like, of course, it kind of depends on the length of the paper, but assuming you're still printing on the same piece of paper every time, or like the same dimension of paper, it's going to be one step. And you know the duration of that step. It's going to be just one step. Like, supply in the data, keep rotating, keep printing. It's just a one-step process. And this is like my theory, this is like in real life why a laser printer is on average, or in worst case, faster than an inkjet or dot matrix printer. Get it? Makes sense, Obi? Because you actually perform like one continuous operation, and it doesn't depend on the complexity of the input data, it doesn't depend on what you're printing. You always move along the paper at the same speed, so it's just like one full process. It's a 3D box, it's too smart. Yeah, okay. So you print the same, like as you can see, you achieve the same result. You get a printed piece of paper with the same image on there. And this isn't to say that the dot matrix printer can't be faster than the laser printer. If you have a very slow laser printer that's printing at a very high definition, needs a lot of time to get the ink or transfer the image onto the paper, the laser printer can be like, it can be slower in real life. So time is not the problem. It's like the algorithmic complexity, like the operation you're trying to do is much simpler in the laser printer, and it's much more like there's no worst case, there's no best case, there's no worst case. It's like always going to take the same amount of time, which makes it like very useful for planning, printing out a lot of pages, whatever that might be on there. And the inkjet dot matrix printer is just like very unpredictable. Like you said, the worst case scenario for inkjet might be a checkerboard pattern or something, where you continuously have to move from the entire left side of the page to the entire right side of the page and do it for every row. That will take a lot longer than like a simple drawing that we have here. But the laser printer, no matter what pattern, no matter what contents of the page you're printing, it will always take the same amount of time. So that's a constant runtime, sort of, and this is a linear runtime. So that's why I thought it would be a very nice comparison to a real-life, step-by-step process, sort of. So algorithmic time and complexity does have nothing to do with time or actual speed of a system or anything. It's about the number of steps and kind of the predictability or like the conditions, the extent of the runtime that you can deduce from the input to the output. So, wow, nice, yeah. Like it's a pretty complex topic in itself, which is sort of a pun. But I hope this kind of makes sense. So, say a big word to Amaze Crunch. Synergy. We're gonna synergize some paradigms here, and we're going to do it like live on the live stream. I want to hug you. That sounds nice. So anyway, so that's algorithmic complexity for a linear search compared to a binary search. So ON compared to O log n. And in printing, ON, which is kind of unexpected because in both cases you print the same page. I mean, you know, it's an A4 like A4 dimensioned piece of paper, but like there's sudden complexity introduced due to the physical nature and the process, the mechanical process that you have to use to get your image onto the paper. So that's a complexity difference between the inkjet and a laser printer. Abracadabra. Synergistic. Sorry. So I hope that's enough for you today, Obi. This is kind of like how algorithmic complexity works. A big O notation is for the worst case runtime, like the upper bound on that. And that kind of makes it more predictable. Or at least you can make more inferences about that than an average runtime. And now the series that I wanted to refer you to, let me see if I can get this working. Sorry. Yeah, I call it Big O. If you look it up, Big O notation, I think you'll probably find it. Big O notation algorithms. Big O notation. That's actually how you call it. That's what I call it. That's what everyone calls it. Big O notation. Yeah, there are Greek things. I think there's like Big Sigma or something, but Big O is definitely the one that everyone uses. This is what I use when developing Angeldust. You take a look at like the worst case algorithmic complexity, what you're using. Okay, like you can use omega, like the capital omega, small omega. But this is what I'm most used with. So here you've got a few examples. Like you said, you've got quadratic runtimes, log n, logarithmic, double logarithmic, okay, constant. Hello, как дела? Hey, Mark Simon, привет, как дела? We're doing fine. And factorial, yeah, sure. Big omega. Yeah, there are subtle differences. But you'll learn all about this in school or when you take a look at this lecture. So let's take a look at this. I'm not sure what it was called. I think it was MIT EDU algorithms. Let's see where we end up. 6006.
The following content is provided under a Creative
MIT
Commons
OpenCourseware,
license.
sure.
Your support will help MIT OpenCourseware continue to offer high-quality educational
information you need about
Yeah, it's this dude.
a prerequisite for this class. Back when Eric
You can win a cushion. You can win cushions in this. He's got a stack of cushions that you can, like cushions, the things that you sit on that you can win. It's pretty memey.
But and there's like and it goes
I'm not sure if this is actually.
and what we're saying.
You see the same shoe boxes. You'll see the same shoe boxes. So this is it. 6006. And then just start at number 1. Not sure if you're actually going to like get all of it if you haven't got any education in this field just yet. For me, it was like very self-explanatory and was very obvious that what was going on. There's a few errors in the video where there are YouTube comments pointing out like, hey, there's an error here and there, and it will definitely like bake your noodle once you're watching it. Like, this doesn't make sense or it sounds incorrect. So never doubt yourself. You've seen this already. Okay, well, watch it again with the knowledge that you have now. Maybe that makes a bit of a difference. I think this professor and the other one, I think this is the assistant.
The following content.
Not sure. Yeah, this is the other dude. So they both, in my opinion, like explain it very well. Start at the very simple base. I do think that the number 6006 kind of gives away that it's not an introductory course, or at least it's not to be given like in the first year of computer science. On the other hand, I found it very accessible. So, oh, you've seen the channel, not the series. Okay, so
Following content.
MIT 6006. It's pretty good. At least I had no problems following it, and I had a blast doing so. So I've watched quite a few of these. I didn't really go into like the end topics. There's I think I made it somewhere to dynamic programming, stuff like this. Sure. And here you get kind of more into practical applications of the algorithms and stuff, and I kind of lost track there. But oh, I see. It's kind of like I was already at the end there. But it's a very nice series. It's a very nice series. Even I'm not sure if you're actually like actively interested in following these. I found them very informative, and like I said, I learned some new tricks, like turning the problem upside down, like looking at the problem from a decision tree, like how many outputs can you have from this algorithm, or like how many different outputs do you want? So what is the minimal complexity of the algorithm that you can use to get there? It was kind of like mind-opening, which is why I have like I liked that this topic came up and that we could talk about it. I shall take a look. Now, just take a look. Like, follow him. Don't skip around. Don't put it at double speed. You need some time to process everything in your head. The information comes at you at a rapid pace already. So just like reserve an hour or so for the 1 or 2 introductory lessons of those, and you'll have a blast. Seen many of them? Great, cool. So like I didn't use those to get like the basics of all of this. I actually had a computer science education, so I my introduction to like these notations and like these kinds of questions and kind of like general mindset, I had it a lot earlier in life already. But it's like these videos were a very good refresher and summary of most of the things that you learn in such classes anyway. So and that's the answer that who was it? Mr. Ram Raider, I think it was 2K6. Can't really find it anymore. I think it was Ram Raider 2K6 who asked like how is the game so fast? How does it work? That's how it works. Algorithmic complexity. Keep that down, and it doesn't really matter what platform you run on, what processor you run on, what language you're using. As long as you make sure that what your program is doing is done efficiently, you're all good. You can actually prove, I think, that sure, you can achieve an 0.1 speed up, like a 2-time or 3-time speed up by maybe moving programming language, but the real performance gains will be in algorithmic optimization. There's no way around that. That's like a universal truth. The less that you do, the faster it will be, like always. And of course you can say like a inefficient algorithm on a very speedy CPU will finish faster than a fast algorithm on a slow CPU. You'd be absolutely right. But that's kind of short-sighted. That's not what this science is about. It's about finding the most efficient algorithm and making sure that you don't do work that's not needed to be done. How did we get here? So for example, let's say you have a lot of objects which have an ID. If you put them in a list ordered by the ID, the O will be O1. I don't really understand what you're trying to say, Obi. Let's say you have a lot of objects which have an ID. If you put them in a list ordered by ID, the O will be O1. The O of what? If you put them in a list ordered by ID, the O will be O1. Are you trying to do an insertion sort? So you have a random set of objects and you want to turn them into a sorted list? Or are you looking up a single element in a list? Or This probably makes sense in your head, but there's a lot of information missing on what you're actually trying to do and what kind of big O you're trying to determine. And you wanted a specific object, you'd only need to look at the nth object. If you're in a database, like Angeldust, you sign in to Angeldust. Haha, yeah. So these are good questions, but maybe you need to take a bit more time, and maybe a YouTube chat isn't the best format to put them in. We can talk about this maybe offline or in a private message. But generally, like the problem that we looked at was actually one of the most fundamental problems I think in computer programming, is looking things up. If you sign into the Angeldust website, if you sign into the Angeldust game, you have this player name that you use, and indeed, behind the scenes, and you actually already know this from the website, you know you have a player number and a player ID or an account ID or whatever. So that account ID subsequently gets used to look up which discovery you've already done, which friends you have, where you want to spawn, which claims you have, maybe which items you have unlocked, and all those kinds of things. And like in a database in general, like the most common problem that I think face in any program that you're making, like for general use, is looking up data by an ID. And then a standard binary search tree, a balanced binary search tree that we saw earlier when I did the example, like that is the like most common and I think most generalized, common and most useful solution for that. So that's why Angeldust is just built upon an SQL database. The database keeps track of this balanced tree. It will actually update the tree when you add a record. It will update the tree when you remove a record or a player. And it's all good. And you just say like, okay, give me everything tied to this ID. Sure, you can go no SQL, no SQL or no SQL, which would have a kind of like a hash map storage for all of these things. And it might be like algorithmically faster, but it has downsides. I mean, I appreciated the data integrity of a database, like ACID compliant, and like having foreign keys actually point to existing players and existing discoveries and existing items. So yeah, don't know really what to say. I think looking up IDs or looking up IDs in a list of stuff, binary search, you can't beat it on average. That's kind of like the thing on average. In a generalized scenario where you don't have specific rules or specific aspects to your data, binary search, it's the be-all end-all solution, I think. Like hash map, unordered map lookup is cool, is great. But then you get into time amortization because you need to expand your hash map when you start adding elements. You need to completely recalculate all of the hashes. It's whatever. Anyway, just do it. That's true. Just do it. Hey, here's the social media post for today. Angelio's probably already gone. I'm not sure. For everyone hanging around. Oh, the picture is a little bit bigger than can fit on the stream here. But it was 2 different shots of Angelio's airship. These were actually taken from the stream, so they're not perfect quality, but I think they look pretty fine and dandy. These were actually taken last week. Hilda in the corner, yeah, casually over here, and on the left side. Hilda on the left, 2 Hilda on the right. It's like, woo, there's a Hilda. These are screenshots from the stream, but Angelio, absolutely magnificent build for 90 minutes. It's still here. I appreciate it, like very good work. Like I said, I was afterwards I was thinking like, should I have given maybe 1 more point to you? Maybe. On the other hand, I think the results and the scoring was accurate. I stand by it. 2 winners. Infamous did a great job with the house. You did an amazing job with this. It's definitely bigger. It's definitely got like more of a theme going than Infamous's build. But Infamous did use the NPC, some of the new blocks in more different combinations. It was a good tie. It was a good tie. The wooden box in the middle. Yeah, here you can see a bit of the Pipo box. It's actually like my microphone was here on this screenshot, so I actually put a bit of this screenshot over there. Yeehaw! Hey, what do you think, Crunchy? Does this boat have 340 horsepower as well? Would you raise this hot rod? This baby? But Angelio, absolutely magnificent that you were able to build this in 90 minutes. I actually saw it, like, you only had 90 minutes. Verified fact to build this, and you did it. So that's why it says winner 1 of 2, airship by Angelio. Maybe next week I will place the house by Infamous on the social media. Maybe I'll find something else to post. But that's it. Mike in the screenshot. Yeah. Mike in the screenshot. So anyway, this was the stream for today. I hope you enjoyed it. I enjoyed the computer science segment. I'm not sure if my explanation was clear enough and if it made sense and if it was a good idea to have this like topic of conversation on Angeldust Live. But it was fun doing it. I hope I was able to at least give like some inspiration and hope that you all learned something from it. It wasn't like the best explanation. It wasn't like the most in-depth explanation. It wasn't like perfect from a didactical standpoint, from like a educational standpoint. But hey, it was something that I wanted to keep light and fresh and just try to share it with you. You enjoyed it too? Great. Wow, cool. It was for you, Obi. Next week, I'm not sure when I will be streaming. It might just be like Saturday at the usual time. But I have like people coming over. And I'm not sure if we're going to the beach or something or whatever we're going to do. So it might be a little bit iffy. I will create a YouTube. Is this dust? No, it's a screenshot. I will see when I will be streaming. I will add it to the YouTube channel. Maybe we'll just chill and I will be able to stream on Saturday evening. I have to see this. I have to see what happens. But it was fun to stream today. It was nice that everyone was here and we did some computer science because we love science. Yeah. So that's that. Let's see other things. Yeah. So we kind of skirted this topic a few times already. Like I said, there's a few things happening in my life which is kind of like more personal instead of game related. They do affect, like these things that are happening, they do affect my ability to work on the game and my at times my motivation to work on the game. And I'm kind of struggling to find a good way to deal with this and to find a good middle grounds or something between my personal life and what I'm doing with the game. I'm really happy with the 3.18 update. There's not many bugs in there, like we found the flats, some of which are sorted under an incorrect color filter. I don't think there are too many bugs otherwise. The game has also been rock solid over the past years already, barring a few like tiny or minor bugs or where people start hanging inside of the outside of the world or something like that. Firefly says, I met a girl. What? Would love to see something more complex than a search or sort though. Well, we did do the printer. And I'll get in school anyway, so it's good. Firefly met a woman, and he is pregnant. This conversation is going nowhere. Yeah, something more complex, Obi. You'll build on this. Watch the MIT lecture. You'll like in no time you will be saying like, okay, maybe take it back a step. Like keep it a little bit more simple. But this is all there is to it. Algorithmic complexity is no more than kind of like looking at the worst case scenario number of steps that you have to perform on a certain input. And you can like sometimes say like it's an O(n) times m algorithm, or it's an O(n) squared, or the square root of n. Like look at algorithms. Dive into this. Buy a book even on data structures and algorithms. It's fun to do. It's really cool. That's what she said. What? I will look at this again and I'll see what the joke is. Anyway, no. So anyway, but I have trouble like finding the right angle and the right words and what to say, because like my life is fortunately not over. So that's the good news. It's not even half over. But no, seriously, it's kind of like difficult. I really dislike mixing in my personal life with the live stream and with the game, because I think those are separate worlds, sort of, kind of, give or take. And of course we had this like short section on my dad a few years ago, which I was talking about earlier today. So luckily I'm not in a similar situation as my dad right now. That's the good news. But I do feel that like some things are starting to weigh down on my involvement with the game and sometimes my motivation to work on it. And it's hard to kind of like find a balance in that, and I need to do that, and I need to take a look at like what's happening and how it's affecting me, and I still need to find the right words for that. So there are no like major problems going on, and it's not like that I'm going to fall over and not be here anymore in 2 weeks or so. Nothing like that. But it's just it's kind of like the first time in my life and in my Angeldust live career where I find myself in this situation where I'm like, okay, how am I going to do this? How am I going to how will I find a balance in this? So so what's the big O of making a kid since you're pregnant? I have no idea. Firefly has dreams and aspires to big things. Take your time, Mr. Firefly. That's what she said. But anyway, fly to Colombia and live your dreams. It's also what I do notice is it's also, I'm not sure how all of you feel about this, but it's also a little bit the I'm not sure what to call it, but like the COVID situation, like for 1.5 years or so, like a little shorter than that, but the world seems to be kind of like a bit smaller and a little bit less lively, and there's just like less things going on in a way, and it's kind of like starting to wear me down a little bit. I'm like, okay, come on, there's like, can we like start getting along again, and can we like start up everything? Like we tried everything we could so far, and like still we have cases here. We have almost nobody enter the hospital anymore, at least here in the Netherlands. Nobody is like dying anymore of this. So can we like start things back up and like get back to like some fun stuff instead? And like maybe we need to admit that like it's a good idea, and that, I don't know. It will end in 2 months, okay? You will end in 2 months. Anyways, so I got a haircut. It's not secret anymore. It's a secret shortcut. It was. There are no secret shortcuts. Deep stuff. I love you. Thank you, Crunchy. Someday we'll raise our hot rods, Crunchy, and we'll ride into the setting sun, and we'll have like tracks by either the Rolling Stones playing, like Jumping Jack Flash or something. We've got the hood down and the window up, and we're like blasting the system, and we're like riding towards the sun, into the sun, towards the sunset. We'll stop by a roadside diner, we'll get some chicken wings, and it will all be good. The end is near. Some huge idiotic kids here went to Spain and we got cases again. And it's insane. Okay. Never go to Spain, come back insane. That's not what you want to do. Anyways. Still streaming? Still streaming. Why? Should I stop, Angelio? I will stop very soon, don't worry about it. But like don't expect the worst or anything, but I just need to put my thoughts a little bit like down on paper maybe, and decide like how, like what's important, what's relevant, what do I want to talk about, what do I actually want to say, what's actually going to happen. I have no idea, so that's all cool. I don't understand how they let them go. Me neither. I have no idea. So apparently the Netherlands, we turned red. I have no idea what this means, but like the Netherlands as a country turned red somewhere. I have no idea where or how. Maybe on Skynet's global map. Netherlands turned red, and that's it. I mean, like I woke up this morning and things were like pretty much still the same as they were yesterday when we weren't red. So you tell me. I thought you ended it and then I came back. No, I never ended, but you did come back. Derive the algorithmic complexity of your thoughts. This is a really hard part. It's not doable. My brain is entirely non-linear. There are so many background processes going on at the same time that I don't even know what all of them are. So I can't really tell you. Anyway, let's call it a day for today. Next week I will be back. I will see if I stream on Friday, Saturday or Sunday. I might just be able to stream on Saturday, regular time, regular place, but like I said, I've got friends over and I want to see what we are going to do and if I can actually stream. Because I don't want to have like someone sitting inside or like being like, okay, this is fun. I went to Firefly and now he's streaming all day long. Turn on the priestess and we'll keep busy. Oh, this is secret. That's a secret. That's a secret. Anyway. I know. Getru want to draw some, and we'll take a look at them. I hope you enjoyed the stream. I hope you enjoyed the computer science segment. I had fun doing it. I hope it was at least a little bit informative, and I hope to see you again next week. So have a nice weekend, have a nice Saturday, have a nice Sunday. Thanks for playing, for all of the comments, and all of the great stories that we shared today. And we'll see each other again next week. Peace out. See you later.